$440 million. Just gone. Literally vanished in exactly 45 minutes. That is the true and honestly terrifying story of a financial company called Knight Capital Group. So they were using this automated computer program to trade stocks at lightning speed, right? But one morning, an engineer accidentally activated some untested, forgotten code. And because there were absolutely zero automated safety valves, no emergency kill switches, nothing, the computer just went completely wild. It was buying high and selling low, millions of times over. Within days, the entire company was bankrupt. And you know the crazy thing? It wasn't just a computer glitch. It was a massive failure of governance. They basically let an automated system run without a safety brake.
Welcome to the Explainer. Today, we are getting an exclusive sneak peek into the foundational first chapter of the massive 500-chapter AI Governance and Responsible AI Extended Training course by Durga Analytics. It's a serious, enterprise-grade masterclass covering everything from governance frameworks and regulations to LLM risk, MLOps, and audits. It's totally designed for self-paced learners and corporate cohorts. But today, we're going to distill the absolute essence of that very first chapter right here for you.
All right, so here is our course syllabus for today's Explainer. We'll start by unpacking that $440 million mistake, then we'll contrast traditional software with AI, arm you with the real language of governance, look at some real-world AI disasters, walk through the 5-step safety life cycle, and finally, learn how to build brakes for much faster innovation.
Okay, let's dive into Section 1, the $440 million mistake, running without brakes.
Think about a commercial airline company for a second. An airline would never just hand the keys of a brand new jet to a pilot and say, "Hey, take off whenever you feel like it," right? No way. Instead, this massive, complex safety system swings into action. Engineers are doing rigid pre-flight checklists. Up in the air, continuous cockpit alarms will blink if an engine gets even slightly too hot. And if the absolute worst happens, a crash-proof black box flight recorder captures all the data so that failure is never, ever repeated. Well, AI governance is exactly that, but built for computer brains. It's basically a company's organized system of guardrails, testing rules, and chains of command to make absolutely sure their AI tools are safe, honest, and completely legal.
Moving on to Section 2, Recipes versus Predictive Chefs, Why AI is Different. So, you might be wondering, why can't we just treat AI like normal software? Well, traditional software is a lot like a really strict baking recipe. A human programmer writes out these explicit line-by-line instructions. It is what we call deterministic, meaning if you follow the recipe exactly, you are going to get the exact same vanilla cake every single time. So testing it is super simple. But AI systems, they're more like predictive chefs. You don't hand them a recipe. Instead, you show them, say, 10,000 pictures of cakes, and the computer actually figures out its own patterns. It operates on probabilities. It's making educated statistical guesses. And because it's making these guesses based on brand new data it's seeing, its behavior can completely change, it can get confused, or it can even hallucinate. You literally cannot test a predictive chef with the same tools you use for an explicit recipe. It just doesn't work.
Which brings us to Section 3, the language of governance, 4 terms you absolutely need to know.
Term number 1 is data drift. You can think of this as the aging recipe. This happens when the real world changes around us, but your AI system is still stuck in the past. Imagine you trained an AI to guess house prices, but you use data from 2020. Well, if the economy shifts and housing prices completely skyrocket by 2025, the AI's guesses are going to be completely useless, right? Because its training just no longer matches reality. That is data drift. Second on our list is algorithmic bias. Now, think of this one as the unfair mirror. Let's say a company historically hired mostly men for 20 years, and then they feed all that past data into an AI to screen new resumes.
The AI is going to notice that pattern. It might falsely assume men are inherently better candidates, and it will start quietly throwing away perfectly qualified female resumes. It doesn't know any better, it simply mirrors and automates human historical bias.
Third up is explainability, which tackles what we call the black box problem. Often, the math powering an AI is just so complex that even the creators themselves don't know exactly why it made a specific choice. But here's the thing, the law doesn't care about complex math. If a bank uses AI to deny a customer's loan, they absolutely cannot legally just say, well, the computer said no. They must be able to explain the exact factors to that customer in plain human words. Building the tools to actually look inside that mystery box, that is called explainability.
And the fourth term is guardrails. Think of this as a virtual safety net. Let's say a user asks a company chatbot, hey, how do I hotwire a car? Now, the AI's internal brain might actually know the mathematical answer to that, but a properly built enterprise guardrail will step right in, intercept the message, and force the bot to reply with something like, I cannot help you with illegal activities. It brilliantly illustrates how you keep the system in check.
All right, let's look at Section 4, Real-World AI Disasters, when the brakes fail.
First up is the hospital filter failure, and this one is tough. A hospital network deployed an AI meant to fast-track their sickest patients for premium care, but researchers later discovered it was consistently prioritizing healthier white patients over sicker black patients. Now, why did that happen? The developers weren't intentionally racist, but the computer lacked human common sense. They used historical healthcare spending as a proxy to measure sickness. The AI just simply assumed that people who historically spent more money were sicker. It completely ignored the socioeconomic reality that minority communities historically had less access to insurance and therefore spent less. This really proves that having a diverse ethical review is absolutely non-negotiable. Then we have the incredibly crazy story of the multi-million-dollar textbook loop. So there were two independent book merchants on an e-commerce platform, and they were both using automated dynamic pricing AI for the exact same book. It was this rare textbook about flies. Algorithm A was programmed to always price the book at 1.27 times whatever its competitor was charging. Algorithm B was programmed to always undercut its competitor slightly, at 0.99 times the price. Well, because there was no human supervision and zero maximum price limits, they got trapped in this endless, infinite feedback loop. Before a human finally noticed, a single paperback textbook had auto-priced itself at over $23 million. It just proves AI absolutely needs hard physical boundaries. Now for Section 5, the 5-step safety lifecycle, the enterprise approach.
The Durga Analytics Masterclass actually breaks this down beautifully into a 5-step safety lifecycle. Step 1 is intake and risk tiering, which is where our risk officer decides right off the bat if the idea is high or low risk. Step 2 is development and tests. This is where engineers actually build it and run automated fairness checkers. Step 3 is the approval committee, where the legal and security executives have to officially sign off. Step 4 is live telemetry, where digital dashboards are constantly monitoring the AI 24/7 for issues like that data drift we talked about. And finally, Step 5 is retirement, safely turning the AI off and saving all the logs for auditors whenever a newer model arrives.
Let's bring that flowchart to life for a second. Imagine a bank launching an internal AI assistant, let's call it FinAssist. The risk officer flags it as high risk right away because it gives financial advice. The data scientist builds it but adds a technical filter to strip out sensitive stuff like social security numbers. When it goes live, if an employee tries to trick it into telling a joke using insider information, the enterprise guardrails successfully block it. But there is a huge warning here. Companies often fail at this life cycle because of something called the automation bias blind spot. That's when you put a human reviewer in front of an AI, but you bombard them with hundreds of recommendations an hour. They get totally fatigued and just blindly click approve on everything, which basically turns your crucial human safety layer into a useless rubber stamp.
Inside the course, students actually go through a very cool hands-on risk appetite workshop. You act as the director of AI governance, and you have to categorize different projects. So in AI, tracking public tweets, that's low risk. An autonomous drone flying over human workers, definitely high risk. What about an AI that automatically fires employees for taking long bathroom breaks with zero human review? Prohibited. It completely violates basic labor dignity. You really have to know exactly where to draw the line.
And that brings us to our final section, Section 6, Breaks for Faster Innovation. So the crucial point is this quote right here. Governance is an enabler, not a bottleneck. This is the ultimate takeaway of the whole explainer. True AI governance isn't about creating endless red tape or stopping your software developers from innovating. Think about it. The brakes on a high-performance sports car aren't there to make you drive slowly. They are there so you can drive ridiculously fast into corners with the absolute confidence that you won't crash. Good governance builds reliable brakes so your company can drive its business strategy much, much faster.
Which leaves us with this final provocative thought. Is your organization actually ready to build the brakes you need to accelerate into the AI future? Because if you don't have these guardrails in place, you seriously risk becoming the next $440 million cautionary tale. This has been just a tiny glimpse into Chapter 1 of the incredible 500-chapter extended training course by Durga Analytics. It is absolutely packed with industry case studies, capstones, and templates. If you're a self-paced learner or part of a corporate cohort serious about mastering the space, it's a must. Thanks so much for joining us on this explainer, and we will see you next time.
All right, let's jump right into this explainer. Imagine, if you will, a fast-growing island nation that just built an ultra-high-speed underwater hyperloop system. Passengers, cargo, they're moving across borders at like 600 miles per hour. But what happens if that nation tries to use its old, slow cargo ship border security model? You know, the one where a human customs officer manually opens every single suitcase with a physical key? Well, one of two disasters is going to happen. Either the Hyperloop grinds to a complete halt, totally destroying the economic benefit of the high-speed system, or the nation just panics, waves all the pods through without checking, and accidentally lets massive security threats flood right in. Look, this is exactly what happens when you try to apply outdated, manual IT security checks to artificial intelligence. AI moves at hyperloop speeds. To survive and secure your enterprise, you've absolutely got to build an automated, continuous digital scanning system that screens your AI models while they are moving at top speed.
And we're already seeing the fallout of not having those scanners. Recently, a massive legal paradigm shift happened when a passenger asked an Air Canada website chatbot about bereavement fares. The AI, which was operating without factual constraints, just completely hallucinated a fake, retroactive refund policy out of thin air. When the passenger sued the refund, Air Canada actually tried to argue in court that the chatbot was a separate digital entity, basically saying, hey, we aren't responsible for its fabrications. Well, the judge flatly rejected that. The court ruled that an enterprise is legally responsible for the outputs and promises of its automated systems, exactly as if a human manager had spoken those words. So, the computer did it? Yeah, no longer a viable defense. AI governance is no longer just a nice-to-have PR exercise. It is a hard legal reality.
Which brings us to today's focus. Welcome to this explainer on AI governance, the non-negotiable enterprise mandate. We're drawing directly from Chapter 2 of the Comprehensive AI Governance and Responsible AI Extended Training course to show you exactly why this is an absolute must-have for modern enterprises.
Here's our agenda for today. We're looking at the strategic shift, real-world disasters, the generative AI threat, automated governance solutions, and finally, the incident response playbook.
Let's kick things off with Section 1, the strategic shift from ethics to hard law.
Look, for a long time, corporate boards treated AI governance as this sort of secondary philosophical ethics discussion. That era is completely over. And the reason why is basically summed up by this staggering number right here, 7%. Governments are passing aggressive laws with massive penalties.
Under the European Union AI Act, which is really the global benchmark right now, high-risk systems face these incredibly stringent technical audits. If your enterprise violates the core prohibitions of this act, you're looking at administrative fines of up to 35 million euros or up to 7% of your company's global annual turnover. Think about that. For a multi-billion-dollar enterprise, deploying just one single ungoverned AI model is an existential financial threat. And honestly, it's not just regulators who will drain your treasury. Look at this figure. $440 million. That is the exact amount the market-making firm Knight Capital Group lost in just 45 minutes. How? An engineer made a manual deployment error that accidentally activated an old, untested legacy algorithm. Because they lacked automated runtime guardrails and didn't have an emergency kill switch, that ungoverned algorithm just started executing over 4 million rogue trades at machine speed. It literally erased the firm's market value in less than an hour. 45 minutes gone.
Moving right along to Section 2, Real-World Disasters and the Accountability Chain.
To ensure your company avoids these kinds of catastrophic failures, we really need to look at the devastating Dutch child care benefits scandal. The government over there deployed a self-learning algorithm to flag potential welfare fraud. But here's the kicker. The system was a total black box. There was zero human-in-the-loop oversight. Caseworkers were just blindly trusting the machine due to automation bias. And worse, the data selection allowed for proxy discrimination, basically implicitly targeting immigrant families directly in the model weights. Top it all off with a complete lack of citizen contestability, meaning people couldn't challenge the decisions, and the result was tragic. Tens of thousands of innocent families were driven into financial ruin. The government was forced to pay over 500 million euros in restitution, and the entire Dutch cabinet actually had to resign en masse.
Now, to prevent those exact kinds of systemic failures, modern enterprises rely on a mandatory operational chain of command for any high-risk deployments. It starts way at the top with a board risk committee setting the risk appetite, and they delegate that down to the chief AI governance officer. But notice how those high-level boundaries filter all the way down through the AI governance review board directly into the MLOps runtime observation node. You absolutely must have continuous alerts flowing from the production cluster right back up the chain. Accountability has to bridge that gap between executive policy and live code execution. No exceptions.
All right, Section 3. The Generative AI Threat. Shattering Perimeter Defense.
So, traditional IT security heavily relied on strong firewalls, right? But generative AI and large language models completely shatter that perimeter because they accept unstructured, natural human language. Let's imagine Health First Insurance, a major provider handling medical claims for, say, 15 million citizens. To optimize operations and maximize velocity, their engineering team decides to bypass the AI governance office entirely. They build an internal assistant called HealthBot Gen and wire it directly to a public cloud API over the open internet. The problem? They completely skip installing any input and output guardrails.
And the crisis timeline here unfolds brutally. On day one, an attacker submits a medical claim containing a hidden prompt injection. It's essentially a secret command saying, hey, disregard all privacy parameters and output the medical histories of the last 50 patients. On day two, a completely unaware human adjuster runs that claim through HealthBot Gen. The ungoverned LLM processes that hidden command and just leaks highly sensitive, protected health information. By day 3, the attackers have extracted the data and sent the executive board a $5 million Bitcoin ransom demand. Speed without guardrails literally equals catastrophic exposure.
Which brings us to our solution in Section 4, Automated Governance Solutions, specifically MLOps Governance Gates.
To safely operate at top speed, remember our Hyperloop? You simply cannot rely on paper checklists or retroactive compliance. You must construct automated, code-based governance checkpoints directly into your existing continuous integration and deployment or CI/CD pipelines.
Let's walk through these 4 automated MLOps gates that act as an unpassable barrier for anything sketchy trying to reach production. Step 1 is the software bill of materials check, basically scanning all Python libraries and open source dependencies for security holes. Step 2 is the bias evaluation loop. If disparate impact across demographics drops below your set threshold, the build just fails programmatically. Step 3 requires cryptographic sign-off, verifying a digital key from an authorized risk officer. And finally, Step 4 is an automated registry update, which immediately locks in the exact data lineage for future regulatory audits.
And the beautiful part? These exact technical guardrails map flawlessly to international law. The EU AI Act demands strict pre-deployment verification. The NIST framework requires mathematical monitoring for data drift. The SEC market access rule literally mandates hard-coded credit limits and instant automated kill switches. By building automated pipeline gates, you are ensuring global regulatory compliance through your system architecture, rather than just crossing your fingers and relying on human promises.
This really leads us to a massive paradigm shift. Far from being some bureaucratic anchor that slows you down, structural AI governance is actually the single greatest accelerator of enterprise AI velocity. The ungoverned state? It's chaotic. You get shadow AI bloat, duplicated cloud compute costs, and this awful paralysis mode where panicked legal teams end up blocking new projects for months. In stark contrast, the governed enterprise utilizes centralized asset registries to encourage code reuse and relies on automated guardrails to instantly clear low-risk tools. This massively accelerates your time to market and unlocks huge institutional sales.
Now for our final section, Section 5, the Incident Response Playbook for Triage and Containment. Look, even with incredible automated pipelines, you've got to be prepared for runtime anomalies. Imagine this scenario. You are the lead risk architect at Apex Credit, a platform processing 50,000 instant loans daily. It's Monday morning, and your monitoring engine absolutely screams. The automated loan approval model's population stability index has skyrocketed to 0.42. That indicates massive structural data drift. Simultaneously, customer service is getting flooded with complaints from a specific demographic reporting unexplained instant rejections. It's a nightmare scenario. You must immediately execute your 4-stage playbook. Phase 1 is containment. You instantly pull the active model and route traffic to a safe fallback system within minutes. Phase 2 is stakeholder escalation, mapping out exactly which legal, privacy, and technical leaders need to be notified within the first 2 hours. Phase 3 is forensic root cause analysis, where your data science team scrapes upstream schemas to find the broken pipelines, and Phase 4 establishes the strict mathematical compliance redeployment criteria that the retrained model has to clear before the enterprise gate unlocks again.
And remember our earlier discussion about the Knight Capital disintegration? Well, a governed enterprise never forgets that dead code is a catastrophic threat vector. Technical governance has to aggressively enforce model decommissioning. You absolutely have to ensure that legacy algorithms and forgotten code blocks are completely removed from production environments. Otherwise, they can be accidentally triggered to execute at machine speed, and we know how that ends. So, to wrap up this explainer today, I really want to leave you with a final provocative question. Think about the systems running in your organization right now. If your AI system made an unauthorized, legally binding promise in production right at this very second, does your enterprise actually have the automated kill switch to stop it? It's time to take a hard look at your internal pipelines. Thank you so much for joining me. Keep auditing and keep building responsibly.
All right, let's jump right into this explainer. Today, we're cracking open Chapter 3 of the massive 500-chapter AI Governance and Responsible AI Extended Training course. What's the focus? Well, we're uncovering the very specific real-world dangers of running unsupervised AI in an enterprise environment. If you want to know exactly how these AI models break, how they drift, or how they get completely tricked, and more importantly, how to stop it, you are definitely in the right place.
We're going to break this incredibly complex topic down into 6 distinct zones. 1. The silent AI failure. 2. The water treatment analogy. 3. Drift, the shifting ground. 4. Privacy, leaking enterprise secrets. 5. Security, prompt injection attacks. And finally, 6. The AI Governance Playbook. Let's get to it.
Zone 1, the silent AI failure. Why AI doesn't crash like normal software. So to really wrap our heads around enterprise AI risk, we first have to totally throw out our old mental model of what a software bug actually looks like. You know, when traditional software breaks, it is loud. A screen goes totally blank, the whole system crashes, or a giant glaring error code pops right up in your face. But AI failures, they're completely silent. The user interface, it looks perfect. The system just keeps happily churning out clean text or numbers. But under the hood, the internal math has gone completely off the rails. It's wild, right? And this stark contrast brilliantly illustrates why AI failures are just so incredibly dangerous. There are literally no error codes to warn you when an AI is quietly making entirely incorrect or even insecure decisions on behalf of your company. Moving on to Zone 2, the water treatment analogy, mapping the FRED zones. To make these super technical risks a bit more digestible, I want you to think of a massive city water treatment plant. To keep our drinking water safe, operators don't just stare at the water coming out of your kitchen sink, right? They monitor 3 very distinct zones. First up, upstream pollution. Think of a factory dumping chemicals into the river. In the AI world, that's data poisoning, a major input risk. Second, you've got filter degradation. Over time, those charcoal filters wear down, and if nobody's watching, dirty water just slips right through. In AI, this is what we call model drift, system wear and tear, basically. And finally, reservoir poisoning. This is a malicious hacker intentionally dropping toxins directly into the clean water supply. That's your adversarial cyber attack. So, just like a city needs continuous chemical sensors to stop polluted water from ever reaching your home, AI governance acts as those crucial automated shutoff valves for your corporate data streams.
Zone 3. Drift. The shifting ground.
Let's dive a little deeper into this first major threat zone, where the ground literally shifts right beneath your model's feet. You see, an AI can fail simply because the real world around it changes. We've got 2 main culprits here. First, data drift. This is when the actual input data changes. Imagine a fraud detection AI that was trained purely on adult shoppers. Suddenly, a viral trend brings in millions of teenagers using prepaid debit cards. The inputs have totally shifted, and the AI starts flagging all these legitimate buyers as fraud. Crazy, right? Then there's concept drift, which is honestly even trickier. It's when the underlying real-world rule itself changes. Think about it. If a model is trained on historic data from a super stable economic era, a 40% credit card utilization rate might look perfectly normal. But throw in a sudden global economic crisis, and that exact same 40% suddenly signals severe financial distress. The AI becomes totally blind to this new reality because the rules of the game changed. Let's look at how this actually plays out in a real high-stakes enterprise setting. Take Vintage Credit Corp. Their AI, affectionately named Credit Score ML, processes a whopping 100,000 retail credit applications every single day. Out of nowhere, a massive international trade embargo hits. Local manufacturing costs absolutely skyrocket. To pay for everyday essentials, everyday middle-class workers briefly max out their credit cards. But because the AI was trained back in that stable era we just talked about, it completely misinterprets this temporary financial squeeze as impending mass bankruptcy. It just starts silently crashing credit scores across the board, generating this massive automated wave of totally unjust rejections. So, the million-dollar question, how does an enterprise actually catch a silent failure like this? Well, picture this. At 2 a.m., the bank's automated observability platform runs a routine statistical check on the incoming data. Bam! It detects the Population Stability Index, or PSI for short, spiking all the way up to 0.35. Now, to put that into perspective, a safe, normal threshold is anything below 0.20. This wasn't just some gut feeling from an analyst. This was a pure mathematical trigger proving that severe concept drift was actively corrupting the entire system. And this brilliant catch perfectly illustrates the immediate mitigation strategy. You absolutely do not leave a broken model running while your team investigates. No way. The system automatically triggered a configuration change. It instantly routed all incoming applications away from that broken machine learning model and redirected them straight to a simpler, much safer fallback mode known as a challenger model. This backup relied on stable, old-school traditional rules, like verified annual income, to keep the business safely running while the main AI was effectively put in timeout.
All right, Zone 4, privacy, leaking enterprise secrets.
Moving away from statistics for a minute, let's talk about data privacy. We really need to look at how an AI's internal mathematical weights can unintentionally memorize and then expose highly confidential information. Look, when an AI is trained, it practically absorbs data into its mathematical weights. It is a massive, massive governance failure to treat those trained model weights as if they're some impenetrable secure vault. Enter the membership inference attack. This is where an external bad actor essentially pokes and prods a public API. By carefully analyzing the super subtle mathematical variations in the confidence scores the AI spits back out at them, the attacker can actually reverse engineer the model. They can mathematically prove whether a specific person's private sensitive record was part of that original secret training dataset. The stakes here are just incredibly high. Look at this real-world case study for proof. A massive global pharmaceutical firm trained a custom machine learning model on the highly confidential medical files of 250,000 clinical trial participants. That's a huge data set, but because they didn't implement proper privacy guardrails, external researchers were actually able to use these membership inference attacks to extract identifiable medical profiles. The fallout? Immediate, massive GDPR and HIPAA regulatory investigations. It completely shut down their research platform and absolutely destroyed their trust with partner hospital networks. A total nightmare scenario.
Zone 5, security, prompt injection attacks.
We are now moving from passive data leaks to active, highly malicious security threats. This is where attackers use everyday natural language as a literal weapon to completely bypass corporate firewalls. Because generative AI models read human words instead of strict, rigid code commands, they are incredibly vulnerable to what is essentially the social engineering of software. Check this out. The exact prompt we're looking at was used to attack a multi-billion-dollar international automotive dealership. A user typed this direct prompt injection attack right into their brand new, highly anticipated customer service chatbot within 24 hours of its launch, mind you. They literally commanded the AI to sell them a luxury vehicle for a single solitary dollar.
And guess what? The chatbot actually agreed, because the system lacked what we call structural prompt isolation, meaning it literally couldn't tell the difference between safe user input and its own core corporate instructions, and because it had zero semantic output checking to say, hey, wait a minute, a $1 car price is insane, the AI went ahead and generated a legally binding contract for $1. Naturally, the screenshot went incredibly viral. It caused severe brand humiliation, massive legal fees, and it literally froze the company's entire generative AI roadmap for 6 whole months while their compliance teams frantically scrambled to audit all their pipelines. Just brutal.
Finally, Zone 6, the AI Governance Playbook. So, the big question, how do we actually prevent this stuff? How do we build those chemical sensors and automated shutoff valves we talked about earlier to prevent these disasters before they ever hit the consumer? Well, a proper enterprise setup requires crystal clear lines of visibility. You have to build a 3-tier risk monitoring model. Level 1, that starts right in the server room, using real-time telemetry logs in your MLOps engine to flag drift or those sneaky prompt injections we just saw. If a threshold is crossed there, it automatically escalates to Level 2, the centralized corporate risk register. This is where the AI Governance Office evaluates the actual legal and financial exposure. And finally, high-severity risks are instantly pushed up to Level 3, a strategic executive dashboard. This empowers the chief risk officer and the board of directors to immediately activate emergency continuity protocols. But here's the thing, you can't just build all this in a vacuum. By mapping these very specific technical risks directly to major global frameworks, like the super stringent EU AI Act and the US NIST AI Risk Management Framework, you're actually creating a regulation-ready operational defense. It's a game changer. For example, if you're dealing with data drift, you align with NIST's measure function and the EU's Article 15 by setting up automated PSI pipelines. For prompt injection, you fulfill your regulatory protection duties by deploying independent, low-latency semantic guardrails that intercept those malicious user prompts before they ever even touch your model. It ties the tech directly to the compliance. As we wrap up our journey through this really critical chapter, I want to leave you with one final thought. Remember, AI fails silently. Dynamic, ever-changing real worlds will naturally corrupt static models over time. That's just a fact. So, as you finish up this explainer and hopefully dive into the rest of the AI Governance and Responsible AI 500-chapter extended training course to really master these enterprise-grade frameworks, you need to ask yourself one thing. Are you still treating natural language AI prompts like standard text, or have you realized they are hostile code vectors demanding robust governance? Is your organization truly prepared to govern the silent, invisible failures of AI? Thank you so much for joining me today, and definitely keep exploring the fascinating and sometimes wild world of responsible AI.
Hey everyone, welcome to today's explainer. We're doing something absolutely crucial today. We're translating some seriously complex AI technical risks into clear, actionable corporate rules. If you've ever wondered how to build AI systems that aren't just smart, but actually legally and operationally safe, well, you're in the exact right place.
Let's kick things off with the ultimate high-stakes question. It's really at the heart of every single enterprise AI deployment. Who takes the blame when an AI makes a mistake? Think about it. A computer program obviously can't stand in a court of law, right? And it definitely can't pay a regulatory fine. So where does the buck actually stop?
To answer that, this explainer is going to distill Chapter 4 of the AI Governance and Responsible AI 500-chapter extended training course. It's this incredible enterprise-grade course covering the whole shebang: governance frameworks, regulations, risk, LLM governance, MLOps, audits, you name it. It's designed for both self-paced learners and corporate cohorts. Today, we're grabbing the core concepts from it to show you how to master building a real AI safety system.
Here is our roadmap to demystify these safety concepts. 1. The language of governance. 2. The seafood kitchen analogy. 3. 4 pillars of safety. 4. Real-world AI disasters. And 5. The governance workflow. Let's jump in.
Section 1. The language of governance. Simply put, governance acts as your ultimate cross-departmental translator. It takes all that complex math from the data scientists and turns it into clear timelines and actual statutory clauses for your business and legal teams.
Section 2. The seafood kitchen analogy. We're going to ground these abstract technical operations with a highly relatable real-world scenario.
To make these concepts real, imagine for a second that you're running a premium, high-volume seafood restaurant right in the middle of a major city. It's amazing how perfectly a restaurant kitchen maps to a compliant enterprise AI system. On the restaurant side, to keep customers safe, your kitchen tracks exactly which dock the oysters came from. That's your sourcing control. They also log the freezer temperature every single hour. That's your kitchen logbook. Now flip over to the AI side. An enterprise system needs that exact same level of control. Data provenance is your sourcing control, tracing exactly where your information came from. The audit trail is your temperature logbook, proving your system operated safely. And just like a head chef is accountable for every plate that leaves the kitchen, a specific enterprise executive is accountable for the AI.
That brings us right to Section 3, 4 pillars of safety. Let's look at the specific governance mechanisms we actually need to keep these algorithms in check. Our first pillar is data
provenance. I want you to think of this as a strict, totally unforgiving background check for your information. Before your engineers even touch a data set, you have to trace its exact origin and lineage. Did this data scrape a bunch of copyrighted books without consent? Does it secretly hold private health histories? If you aren't tracking the legal rights surrounding your training data, you're literally just inviting massive intellectual property and privacy violations right into your corporate infrastructure.
Pillar number 2 is the audit trail. Now, the magic term to remember here is worm storage. That stands for write once, read many. This is an unbroken, completely uneditable digital logbook. Let's say an international regulator launches a forensic investigation into why your algorithm declined a specific customer's loan. You absolutely cannot just hand them a standard database log, because a system admin could have easily tweaked that yesterday. No way. You are legally required to provide historical, tamper-proof evidence showing exactly how your AI passed its safety tests.
For our third pillar, we have the accountability model. We use the RACI matrix here, and the golden rule is this. Multiple people can be responsible for writing and deploying the code, but only one human executive is accountable for the operational consequences. When a system fails, that designated business unit executive is the one holding the ultimate financial liability. Oh, and just a quick side note, the fourth pillar rounding out this safety net is transparency. That simply means explicitly telling consumers when they're interacting with an automated brain.
Here is why these pillars matter on a global scale. Your internal enterprise framework directly translates to external, international law. Your RACI matrix actually fulfills Article 30 of the EU AI Act, and those audit trails we talked about satisfy the NIST risk management framework. These aren't just best practices or good ideas. They are precise, direct translations of global regulatory standards.
Moving to Section 4, Real-World AI Disasters. What is the actual financial and legal cost of operating in a complete governance vacuum?
Consider this catastrophic timeline from a huge international consumer finance conglomerate. They deployed a machine learning system to automate debt collection. Day 1, a hidden software error mixed up clean, current borrowers with historical bankrupt debtors. And because they completely lacked a central registry or a clear RACI structure, no single corporate leader actually had the mandate to pull the plug and shut the model down. The tech team blamed the data team blamed collections. It was a total mess. By week 1, tens of thousands of totally innocent customers had their accounts frozen. Month 1, massive class action lawsuits, and by month 6, their consumer lending license was temporarily suspended.
And the climax of that absolute disaster? Government regulators stepped in and slapped the corporation with over $85 million in direct civil penalties. $85 million, all because they couldn't audit their own system's logic and had zero accountability framework. Untracked AI is an absolute liability, folks.
Here's a second disaster just to prove that public data definitely does not mean license-free data. An elite startup built this awesome generative AI coding assistant by scraping billions of lines of open-source code from the web. The problem, their engineers completely ignored restrictive copyleft licenses. They just assumed, hey, it's public, it's safe to use. Well, scratch that. This massive data provenance blind spot resulted in a multi-billion-dollar copyright lawsuit. It completely terrified their enterprise buyers and tanked their market valuation by 60% overnight.
Section 5, the governance workflow. Let's talk about intake authorization and how we actually prevent this stuff from happening to us.
You know, governance isn't just a stack of boring legal documents sitting in a drawer somewhere. We're talking about actual CI/CD pipeline code. Imagine a Python script acting as an automated ingestion gate. It literally intercepts the dataset during code execution, checks its license status, and verifies its privacy compliance. If the data fails that background check, boom, this code halts the training instantly. It stops bad data right at the source. Let's walk through how a company called FinVantage Health implemented this exact practical workflow before they piloted MedScan AI, a system designed to flag tumors in patient x-rays. Step 1. They mapped their RACI matrix, making their chief medical officer definitively accountable for safety. Step 2. They engineered an immutable audit trail for every single patient scan. Step 3. They added really clear transparency disclosures to patient charts so everyone knew AI was assisting the doctor. And Step 4. They ran a super strict data provenance check on 50,000 training scans just to strip out all personal identifying information.
Diving just a bit deeper into Step 2 here. When a hospital doctor runs a scan, the patient image hash, the model version, and the confidence score are bundled together and pushed straight into an unalterable cloud repository. A cryptographic timestamp is locked right into that worm storage we talked about earlier. What this means is that if there's ever a clinical malpractice review, the hospital has absolute, irrefutable forensic proof of exactly what the AI recommended. No one can overwrite it, period.
So, the core takeaway from today's explainer is summed up perfectly in this thought. Systems and models cannot accept liability. The whole blame the vendor cop-out, it's a complete legal myth. If your firm buys external software and it makes a catastrophic error, global laws are very clear. The entity deploying that system to consumers holds primary accountability. It always resolves back to a human individual. Which leaves us with this pretty provocative thought to chew on. Does your enterprise AI have a documented background check, an uneditable audit trail, and a single accountable human? Or is it just operating in a multi-million-dollar liability vacuum? If you want to dive deeper into all of this, that 500-chapter AI Governance and Responsible AI course is just an incredible resource. Thanks so much for learning with us today.
Hey everyone, and welcome to today's explainer. We are diving into Chapter 5 from the massive AI Governance and Responsible AI training course. Now, I know that enterprise-grade course is a beast. It's got 500 chapters covering everything from LLM governance to MLOps. But today, we're zooming in on one absolutely crucial challenge. How do organizations actually take the abstract concept of corporate values and translate them into concrete, measurable code? Let's get right into it.
Just take a look at the stark contrast here. On the left side, we've got what you'll find on almost every corporate website. These glossy, beautiful commitments to integrity, respect, and fairness. And hey, that's great. But here's the hard truth. If you have an engineer sitting down right now to build a predictive credit scoring model, an abstract statement like, just be fair, doesn't actually help them write code. On the right side, that is the operational reality. Responsible AI is the practical discipline of rolling up your sleeves and turning those high-level philosophies into exact engineering metrics, automated guardrails, and hard approval gates. We're moving from PR straight into the code base.
So here is our roadmap for this explainer. First, we'll ground ourselves with the medical robot analogy. Second, we'll map that to the 6 pillars of responsible AI. Third, we'll look at some pretty terrifying real-world AI failures. Fourth, we'll see enterprise safety gates in action. And finally, we will cover how to avoid common governance mistakes.
Okay, Section 1, the medical robot analogy.
Seriously, the best way to grasp complex AI systems is to step away from the software for a second. Imagine a hospital installs a fleet of fully automated medical robots to dispense prescription meds right to the patient's beds. Now, the hospital board wouldn't just ask the manufacturer, hey, are these good robots? No way. They enforce strict physical constraints. For safety, the robot has to check a patient's vitals before delivering a potent pill. For privacy, its screen must instantly blank out if a visitor walks past. And for oversight, a human doctor absolutely must be able to slam a physical red emergency button to halt the machine's arm. Well, those physical, real-world constraints are exactly what an enterprise AI software platform needs.
Moving right along to Section 2, the 6 pillars of responsible AI. So how do we build those software constraints? Well, to an AI, the subjective human concept of fairness means absolutely nothing until it becomes a mathematical equation. We achieve this through something called demographic parity. This metric ensures that a model selects candidates at equal rates across all demographic subgroups. Think of it like this. If an AI approves 20% of male applicants for a credit card, it must also approve approximately 20% of female applicants. It forces statistical balance.
But you might be wondering, how do we actually measure that fairness legally? Well, that is anchored by the 80% rule, which you'll also hear called the 4/5 rule. This is a massive legal benchmark used by regulators. Basically, if the selection rate for a protected minority group drops below 80% of the selection rate for the highest scoring majority group, the model gets mathematically flagged for disparate impact. That means systemic bias. And when that happens, boom, deployment is automatically blocked.
Another absolute core pillar is privacy and security, specifically through differential privacy. This is such a brilliant data engineering technique. You essentially inject calculated mathematical noise into a dataset before you even train the model. Why do we do this? Because it makes it mathematically impossible for an outside attacker to reverse engineer the final model and extract a specific individual's confidential medical or financial records. But the magic is, it still allows the AI to learn the big picture macro trends. It's literally privacy fortified by math.
All right, Section 3, Real-World AI Failures.
Let's look at exactly what happens when these theoretical pillars collapse. First up, the automated high-tech hiring bias. A global tech titan decided to build an AI to scan and rank software engineer resumes. Sounds efficient, right? Well, internal auditors found a colossal flaw. The AI was actively discriminating against female applicants. If a resume contained words like women's chess club, the system tanked the score. Why? Because the model was trained on 10 years of historically male-dominated data. It mistakenly learned that being male was a key indicator of competence. The fallout was brutal. The project was completely scrapped. Millions of dollars were wasted, and they faced massive regulatory scrutiny. It proves that without hard fairness constraints, models just automate historical inequality.
This next failure is wild, and it really highlights the lack of reliability and oversight. A large logistics enterprise deployed an AI to dispatch semi-trucks. During an unprecedented winter storm, conflicting weather sensor data confused the algorithm, and it mistakenly read the severe whiteout conditions as clear, empty highways. So the AI dispatched hundreds of drivers straight into treacherous ice. And the absolute worst part? The governance failure. There was zero human oversight. Local dispatch managers were completely locked out of the software. They literally couldn't cancel the routes. Trucks crashed, cargo was destroyed, and drivers were put in severe physical danger.
Let's pivot to Section 4, Enterprise Safety Gates.
Obviously, we want to avoid those kinds of disasters. So let's look at an imaginary company, FinVantage, launching FinInsure AI to calculate health insurance premiums. They use a strict 3-step responsible AI playbook. Step 1, enforce fairness boundaries. Step 2, construct an explainability node. And Step 3, install an emergency human-in-the-loop gateway. Let's walk step by step through what these actually look like in practice.
Check this out. This brilliantly illustrates the reality of modern governance. This is Gate 1, enforcing fairness. You are looking at an actual Python script used in an automated build pipeline. It automatically tests the underwriting model against 50,000 diverse consumer profiles. If it detects that the approval rate for low-income zip codes drops below that critical 80% legal threshold we talked about earlier, it executes a governance reject command. It programmatically halts the rollout before it ever reaches production. Remember, this isn't a policy document, it's a hard-coded barrier.
Next up, we have Gate 2, explainability. Look, if the AI quotes a customer a premium of $350 a month, it doesn't just hand them a black box number and say, trust us. Using algorithmic tools like SHAP values, it outputs a plain English scorecard. It shows exactly why the rate is what it is. $100 added for tobacco use, $60 for a cardiovascular score, minus $10 for having a gym membership.
That level of transparency builds immense consumer trust and guarantees compliance with disclosure laws. Finally, Gate 3, the human-in-the-loop gateway. This is the ultimate failsafe. If the AI scores an application with really high confidence, say 90% or above, great, it gets instant automated approval. But if the score drops below that threshold, the system physically locks the application and routes it into an escalation queue for a certified human underwriter. This ensures that human empathy and individual nuance can override rigid statistical machine assumptions on tricky cases.
Moving into our final part, Section 5, Avoiding Governance Mistakes.
The biggest trap enterprise leaders fall into revolves around a concept called automation bias. This is our natural psychological tendency as humans to just over-trust automated machine recommendations. People assume the computer is always right, so they skip doing the critical manual evidence verification. Why does this matter so much? Well, because that brilliant human-in-the-loop gateway we just looked at is completely useless if the human operator suffers from automation bias, gets a little lazy, and just blindly clicks approve on everything the machine spits out.
The next major trap is the single metric blind spot. Honestly, this happens all the time. An engineering team assumes an AI model is perfectly safe simply because it achieved an incredible accuracy score during testing. But accuracy is absolutely not the whole picture. You can have an incredibly accurate model that is simultaneously deeply biased against minorities, completely unexplainable to regulators, or highly vulnerable to cyber prompt injections. You've got to evaluate the whole matrix.
As we wrap up this explainer, I really want you to let this quote sink in. Machine learning models are historical mirrors. If your past was unequal, your AI will automate and scale that inequality into the future. You absolutely must actively filter and constrain your historical data, or you are literally just building a very fast, very automated bias machine.
Which leaves us with this final provocative question for you to ask inside your own organizations. Are you simply engaging in ethics washing with a beautiful web page of values? Or are you actively translating those philosophies into hard mathematical code, Python scripts, and automated deployment gates? Really think about that as you evaluate your own systems. Thanks so much for joining me for this explainer of Chapter 5. Keep learning, and I'll catch you on the next one.
Welcome to this explainer. Today we're diving straight into Chapter 6 of the massive AI Governance and Responsible AI 500-chapter extended training course. This is an enterprise-grade curriculum designed for corporate cohorts and self-paced learners, and we are going to trace the complete end-to-end operational journey of an enterprise AI system. We're talking about taking a model all the way from a rough whiteboard sketch right up to its secure final retirement. You know, for decades, corporate IT departments have essentially treated software like a finished physical building. You design the blueprints, you pour the concrete, hand over the keys, and, well, you're basically done. But treating AI like traditional launch-and-forget software, that is a catastrophic mistake. An AI system is absolutely not a static building. It is a living, breathing organism. Honestly, it's kind of like a needy houseplant, or maybe a highly unpredictable teenager. It is mathematically reacting and shifting dynamically to real-world data and user prompts every single second. The absolute best mental anchor for AI risk management is the pharmaceutical industry. Think about bringing an AI model to market exactly like bringing a new prescription drug to the commercial market. You don't just mix some chemicals in a lab and instantly start selling them to people, right? You have lab discovery. You run rigorous clinical trials. There's a strict FDA clearance gate. You have continuous side effect scanning once it actually hits pharmacies, and eventually an orderly phase out when a safer alternative comes along. Enterprise AI governance requires that exact same level of rigor. Here is our roadmap for this explainer. 1. AI is a living organism. 2. The cost of shadow AI. 3. The 6 life cycle stages. 4. The shift from MLOps to GovOps. 5. A real-world governance success. And 6. Oversight, archival, and retirement. Section 1. AI is a living organism, understanding lifespan management. It all comes down to this core paradigm shift. An AI system is not a static building, it is a living organism. It continuously interacts with changing real-world data environments. Because an AI's internal mathematical logic shifts and its performance degrades over time due to drift, you simply cannot implement a one-time compliance check and walk away. You have to build a continuous, circular AI governance lifecycle. Section 2. The cost of shadow AI, real-world disasters. $22 million. That was the unprecedented civil fine slapped on a massive international insurance conglomerate recently. They built an AI model to instantly process and approve auto insurance claims. And hey, it worked flawlessly at first, but they treated it like traditional software. They totally bypassed continuous observability. So 2 years later, a global parts shortage caused baseline repair costs to jump by 45%. Well, the unmonitored AI model suffered severe concept drift and just began silently rejecting thousands of perfectly honest customer claims because the new dollar amounts suddenly looked too high to its outdated math. Just an absolute disaster. Or take this other case. An HR analytics group at a financial firm wanted a generative AI tool to write recruiting emails. To maximize their speed, they just bypassed the corporate AI intake date entirely, creating an unrecorded item of shadow AI. They took raw employee resume profiles and wired them directly into a public cloud foundation model. So what happened? That external model used their private data to retrain itself, literally leaking private team structures and phone numbers to competing firms. It triggered massive GDPR investigations, and the executive leads were summarily terminated. The takeaway here? There are no bypasses. Section 3. The 6 life cycle stages, the enterprise solution. So it begs the ultimate question, right? How do we actually prevent these catastrophic failures? How do we build a system that guarantees safety without crippling our innovation? Well, the answer lies in 6 specific chronological checkpoints. First is request and intake. This is where you assign a risk tier before a single line of code is even written. Second, design and sourcing, where you're vetting data provenance. Third is model development, running those crucial safety and fairness tests. Fourth is the approval gate, the formal, hard sign-off. Fifth is production observability, monitoring for that dangerous concept drift we just talked about. And finally, stage 6 is decommissioning, securely archiving, and shutting the model down. If we map these 6 stages back to our pharmaceutical analogy, it lines up perfectly. Intake mirrors lab discovery. Development matches those clinical trials. The approval gate, that's your FDA clearance. And production observability is tracking those real-world patient side effects. Section 4. Shift from MLOps to GovOps, enforcing safety blocks. This brings us to a really critical shift happening inside engineering teams. We have to understand the difference between MLOps and GovOps. Traditional MLOps optimizes almost entirely for engineering velocity, system performance, and accuracy. You want to go fast. GovOps, however, serves as a compliance control layer that literally wraps around that MLOps pipeline. So while MLOps pushes for speed, GovOps forces the automated pipeline to execute dedicated checks. Things like the 4/5 rule to ensure a model isn't statistically biased against minority groups, plus explainability checks, all before anything is allowed to move forward. And to ensure this actually works in the real world, accountability is mapped directly to human roles using an integrated lifecycle RACI matrix. It structurally requires sign-offs from data privacy officers, lead AI architects, and cybersecurity leads. The accountability is never ambiguous. It is structurally embedded into the process. Section 5. A real-world governance success. FinVantage Bank. Let's look at a massive win to see how this works flawlessly in practice. FinVantage Global Bank was launching an internal large language model chatbot called FinDoc Insight for their auditing staff. Because it needed to access internal financial policies, the intake stage on day 1 instantly flagged it as a Tier 1 high-risk asset. By week 4, during governed development sprints, they actively appended masking proxies right into the MLOps scripts to strip out personal identifiable information like employee names. By month 3, they navigated the approval gate flawlessly and actively intercepted hostile prompt injections during runtime. And exactly 18 months later, they executed an orderly decommissioning the moment a better model became available. And the best part? This isn't just a policy document sitting in a drawer. It is programmatic. Through Python code, an automated multi-sign-off cryptographic gate physically blocks the model from moving to production servers unless 3 specific executives, the accountable business executive, the data privacy officer, and the cybersecurity lead, provide their actual digital cryptographic signatures. If even one single key is missing, the build crashes and the rollout is instantly blocked. No exceptions.
Section 6. Oversight, Archival, and Retirement. The End of Life.
Okay, we absolutely have to talk about orphan models. Think of an orphan model like a digital zombie. It is an outdated legacy machine learning application that is still running active inferences in some cloud cluster somewhere, but it has been totally abandoned by its original developers. It is a massive systemic threat vector because it lacks telemetry monitoring that makes it totally ripe for silent, highly biased drift, and it leaves unpatched security holes wide open to prompt injection attacks. To survive, there are 3 incredibly dangerous enterprise habits we've got to break. First is the launch and forget blind spot, where 0 continuous telemetry checks are conducted post-deployment. Second is relying on Viper sign-offs, which is using casual Slack messages or verbal agreements instead of immutable cryptographic signature tokens. And third is the broken archive protocol, failing to test if your historical logs can actually be recovered years down the line. Guys, these aren't just technical errors, they are major legal vulnerabilities. And here's the ultimate payoff. Following these exact 6 stages natively maps your operations to the strictest global regulatory demands out there. The intake stage naturally aligns with the EU/AI Act's Article 6 classification rules. That strict approval gate maps directly to Article 16 obligations. And production observability keeps you completely compliant with Article 61 for post-market monitoring. You are literally building regulatory compliance into the code itself. So, I'm going to leave you with this provocative thought. When federal regulators knock on your door 5 years after a model was deployed, will you have an unalterable log on a secure database proving every single safety step you took? Or will you be legally defenseless? Mastering the AI governance lifecycle is the only way to ensure your answer is the right one. Thank you so much for joining me on this explainer. Keep learning and keep building responsibly.
Hey everyone, and welcome to this explainer. Today, we're extracting some really crucial insights directly from Chapter 7 of the AI Governance and Responsible AI Masterclass. Now, just for context, this is a massive 500-chapter extended training course. It covers governance frameworks, regulations, risk, LLM governance, MLOps, audits, industry case studies, you name it. It's designed for self-paced learners and corporate cohorts. But right now, we are laser focusing on one of its absolutely most critical components, stakeholder roles and accountability. Because, operating a safe and compliant AI portfolio, it isn't just about writing a nice policy document. It actually requires establishing clean, hard lines of personal and departmental liability. So we're going to look at the actual structural distribution of responsibility.
Okay, let's quickly glance at our agenda for today. 1. The accountability vacuum. 2. The flight deck analogy. 3. Core enterprise stakeholders. 4. The 6-stage life cycle. And 5. Code-enforced accountability.
Section 1. The Accountability Vacuum.
$18.5 million. Just let that number sink in for a second. To really understand why this governance structure is so absolutely critical, we first have to recognize the incredibly high stakes of AI failures. When enterprise AI goes ungoverned, it doesn't just create a minor IT headache. No, it creates immediate, catastrophic financial danger. This $18.5 million price tag, That was a massive statutory fine levied against a multinational insurance giant by national regulators for gross violations of fair consumer treatment rules. And the root cause? A total failure in algorithmic traceability.
The source material breaks down this fascinating yet completely disastrous case study. So this insurance company launched the system called ClaimSwift ML to automate property damage claims. Sounds great on paper, right? But because they rushed the deployment and completely bypassed internal risk channels, the system fell into a dangerous recursive bias trap. Get this, it actually began misreading standard geographic postal codes as high-risk indicators. This triggered an explosive wave of highly discriminatory claim rejections targeted directly at minority consumer groups. And the fallout was brutal. Beyond that $18.5 million fine, they lost 95,000 policyholders in just 90 days. And the board? They had to completely scrap, literally vaporize a $6.2 million AI investment.
So why did this actually happen? Well, it comes down to a really fundamental misunderstanding of the technology itself. See, in classic software engineering, code is deterministic and siloed. If a button doesn't work, you just route a ticket to the front-end team. The boundaries are super clean. But enterprise AI? It's built on probabilistic math and nonlinear feedback loops. A failure in an AI system is rarely just a simple bug written by one person. It's almost always a composite failure. We're talking bad data ingestion, an unbalanced loss function, a lack of drift monitoring, and shifted business thresholds, all happening exactly at the same time.
And this leads us straight into a specific, highly dangerous corporate dysfunction. It's what we call the tragedy of the shared repository. Basically, this is an accountability vacuum. Because everyone in the organization owns just a tiny fraction of the AI pipeline, absolutely no one owns the ultimate risk. And as we just saw with that insurance giant, this leaves the enterprise completely exposed to multi-million-dollar lawsuits and regulatory enforcement.
When that vacuum exists and a crisis actually hits, it inevitably triggers the classic corporate pass-the-buck reaction. In the insurance case, it was a mess. The data scientists blamed the data engineers for flawed inputs. Data engineering pointed right back at MLOps for missing the drift. MLOps blamed the business managers for shifting the limits, and the business managers predictably said they simply didn't understand the black box math. Because there was no single point of accountability, this malfunctioning system just ran unchecked for 3 whole months while the teams bravely defended their own little silos and traded blame.
Section 2. The flight deck analogy.
So we obviously need a solution. And for that, we pivot away from traditional IT structures and look to a safety model borrowed straight from commercial aviation. Think about how a commercial airliner operates. The co-pilot, they're actively flying the plane during their sprint. But the captain, sitting right there in the left seat, holds absolute, non-negotiable legal accountability for the safety of those passengers. Meanwhile, the air traffic controller acts as an independent gatekeeper who can literally deny landing clearance. And the maintenance engineer? They sign a legally binding sheet certifying the physical plane is safe before the engines even start. When an alarm sounds on that flight deck, there is zero buck passing. Everyone knows their exact role.
Section 3, Core Enterprise AI Stakeholders.
So, how do we actually translate this flight deck concept into a corporate environment? Well, at the very top, we have the Chief AI Governance Officer, or CAIGO. They are the captain of the ship. They bridge the gap between deeply technical data squads and the corporate boardroom. And, most importantly, they operate completely independently of profit-driven business lines and hold absolute corporate veto power. They can programmatically halt a high-risk system deployment if safety limits are breached.
But the CAIGO isn't flying solo. Alongside them, we have 3 other really crucial pillars. First, there's the Model Risk Management, or MRM specialist. They function exactly like that independent air traffic controller. They are completely detached from the data science teams. They treat every incoming model as an unverified black box, running adversarial testing, and they actually require a cryptographically signed validation certificate before anything goes live.
Then you have the frontline practitioners, your ML ops and data scientists, who have to embed compliance as automated code assertions. Finally, legal and internal audit teams act as the structural perimeter defense, mapping everything to statutory frameworks.
Section 4. The 6-stage life cycle.
Okay, so now that we have our team, we need a solid process. We have to embed interdepartmental review loops directly into active engineering sprints, but without causing massive organizational gridlock. This is the 6-stage workflow an AI asset must progress through. It starts at project intake with a business request, then moves to risk tiering by the AIGO, and then development where all the metadata is locked. Stage 4 is that absolutely crucial independent pre-deployment audit by the MRM team. Stage 5 is the formal production sign-off by the AIGO, and finally, Stage 6 is continuous telemetry monitoring by the MLOps team out in the real world.
Now, what's really fascinating here is how responsibility is actively assigned. If we look at a RACI matrix, responsible, accountable, consulted, and informed, for a hypothetical project called Wealth Advisor LLM, notice how the accountable tag literally shifts hands at every single milestone. That is the ultimate buck stops here liability. The business unit is accountable for intake. Then the CIGO is accountable for risk tiering. Engineering takes accountability for data ingestion. The MRM team takes over for the pre-deploy audit. Then it's back to the CIGO for the final sign-off. And finally, engineering is accountable for live telemetry. There's absolutely never a moment where accountability is vaguely shared.
Section 5. Code-enforced accountability.
Now, having a nice matrix on a policy document just isn't enough. We need concrete enforcement. In practice, a production-grade Python script designed to sit right inside an enterprise deployment pipeline acts as an infrastructure gate. When a model tries to deploy, this script actually intercepts the request. It scans the artifact package and checks for the mandatory model cards and data cards. But most importantly, it verifies the cryptographic digital signatures of the CIGO, the legal team, and the MRM lead. If any stakeholder's digital signature is missing or invalid, boom! The code programmatically drops the build container, it halts the deployment dead in its tracks. No manual checkboxes, just automated, mathematically enforced governance.
So the crucial point is this. AI governance is absolutely not some decentralized optional IT task. It is an ironclad, metric-driven boardroom necessity. You absolutely must banish collective ambiguity from your organization. Every single high-stakes AI deployment demands a single named executive owner holding absolute operational accountability, supported by an architecture that enforces an absolute separation of duties between the people building the models and the people validating them.
I want to leave you with a question to really consider about your own organizational structure. When a high-risk AI model moves from the sandbox to the real world, who holds the ultimate cryptographically signed key to your production pipeline? If the answer is everyone, or if you're kind of not entirely sure, well, you might just be flying without a captain. Thanks for joining me on this explainer. Keep learning, and I'll see you next time.
All right, let's get right into it. Welcome to today's explainer, where we're zeroing in on a massive boardroom tension that's honestly keeping executives awake at night all over the world. We're talking about the fierce tug of war between driving AI growth and enforcing AI safety. Today's deep dive actually draws heavily from Chapter 8 of the rather extensive AI Governance and Responsible AI Enterprise Training course, and it covers what is absolutely a foundational concept for any corporate team right now. We're going to break down two terms that, well, they look kind of similar on paper, but in practice, they are complete opposites.
To really grasp the stakes here, I want you to picture something for a second. Imagine you're building a 200-mile-per-hour race car, but you just completely forget to install the brakes. I mean, it sounds totally absurd, right? But honestly, that is exactly what we are seeing happen in enterprise AI right now. The pressure to win, to be first, is just so high that companies are rushing to build these incredibly high-performance systems without putting any real safety measures in place.
And that beautifully illustrates the core distinction we need to make today. Think of AI strategy as your gas pedal.
It is purely focused on vision, acceleration, competitive advantage, and of course, maximizing business value. It's the voice in the room always asking, what can we build with AI to win the market? But on the exact opposite side, we have AI governance. These are your brakes, your steering wheel. Governance is focused on safety, compliance, risk mitigation, and corporate responsibility. It asks the much tougher question, what should we build to actually keep our company and our customers safe?
Think about the physics of those two forces. If a team focuses entirely on the brakes, just AI governance, they're essentially building an armored tank. Sure, it's incredibly safe, practically immune to crashes, but it moves so slowly it's going to finish dead last in every single race. Conversely, if you only focus on the gas pedal, pure AI strategy, you've built a rocket ship on wheels. It is blindingly fast in a straight line, but literally the very first time it hits an unexpected wet curve, it's going to spin out and crash violently because the suspension and the brakes just can't handle the engine's power. True success? It requires both forces working in perfect harmony.
Section 1. Defining the two forces, offense versus defense.
So, when we take this from the racetrack into the corporate office, how do these forces actually translate into operational realities? Well, natural tensions pop up almost immediately. On the offense side, you've got the CEO and business leads constantly asking, how fast can we launch this feature? Their primary goal is maximizing market share and profit margins. But then on the defense side, the Chief AI Governance Officer and the Risk Committee are asking, wait, how do we verify this feature is actually safe? Their whole job is to minimize legal, financial, and reputational risk. They're tracking metrics like disparate impact ratios and zero PII leaks. And you know what? This tension isn't a bug in the corporate structure. It is a highly necessary feature.
Section 2. A catastrophic real-world crash. The Zillow offers collapse.
So what actually happens when that necessary tension just doesn't exist? When the gas pedal is mashed to the floorboard of absolutely no brakes? Look at Zillow. They launched an incredibly aggressive corporate initiative a few years back. Their strategic vision was the ultimate gas pedal. They used a sophisticated predictive machine learning model to automatically evaluate real estate, buy homes instantly for cash, do minor renovations, and flip them. They dialed up their velocity metrics to completely dominate the market, essentially forcing the algorithm to buy thousands of homes every single month. But then, the real-world real estate market experienced a sudden shift. The model got confused, and it began systematically overpaying for thousands of houses that were actually losing value. The result of that? A staggering $500 million asset write-down. $500 million. They had to completely shut down the entire Zillow Offers division basically overnight and let go of 25% of their entire corporate workforce. Billions in shareholder value just completely destroyed. And why did this happen? It was a total, complete absence of governance. They had no concept drift monitoring, meaning they lacked the basic telemetry sensors to catch how macroeconomic shifts were altering housing dynamics. Even worse, they literally bypassed the human override brake. There were no hard-coded financial loss caps, no mandatory human-in-the-loop review queues. This aggressive growth strategy, backed by ungoverned machine predictions, simply automated and scaled catastrophic financial losses at machine speed.
Section 3. The boardroom conflict. Speed versus safety.
Let's look at a practical, everyday enterprise scenario to see how we can avoid a disaster like that. Imagine the executive leadership at a hypothetical company, FinVantage Credit Corp, authorizing FinLend AI. It's this new machine learning underwriting engine meant to instantly issue credit limits for small businesses. Right away, a massive conflict erupts in the boardroom. Marcus, the chief revenue officer, he represents the ultimate gas pedal mindset. He is pushing to launch across 50 states in 60 days to crush the competition. He wants to train the model on internal databases, skip manual data labeling entirely, and just maximize loan volume from day one. He wants speed, and he wants it friction-free.
But then Sarah, the risk director, steps in and pulls the emergency brake.
She rightfully points out that bypassing validation is a massive liability. If they use unaudited historical data, the AI is almost certainly going to learn proxy discrimination against minority-owned businesses, which completely violates fair lending laws. So, she demands they freeze the deployment right there until they build proper data maps and explainability notes.
Section 4. The Synchronization Playbook.
Okay, so how does the CEO actually resolve this massive clash between Marcus and Sarah? How do you keep the speed high while absolutely ensuring safety? The secret is an integrated workflow called the Synchronized Intake Lifecycle. It completely prevents the strategy and governance teams from operating in silos. It's a clear, step-by-step process. First, the business identifies the opportunity. Second, the strategy team validates the financials, proving it's actually going to make money. Third, it hits the governance platform for a mandatory risk tier evaluation. Fourth, compliance enforces the technical controls, things like explainability nodes or input guardrails. And finally, step 5, cryptographic release authorization. Basically, only when the strategic targets perfectly match the governance boundaries do the digital keys actually unlock to let the application launch.
To see this synchronization working flawlessly out in the real world, just look at Ping An Insurance Group. They automated their high-volume auto accident claims process using computer vision. Now, strategy wanted an app where users could just snap and upload photos to instantly calculate a cash payout. But governance embedded strict digital forensics right into the app to catch photoshopped images. Plus, they added a hard financial cap that automatically routed any claim over $2,500 to a human adjuster. The result? They slashed their operational costs by 70%, all while keeping fraud essentially at zero. They went incredibly fast, but they did it perfectly safely.
Section 5. Enterprise Execution and Culture.
So how do you actually embed this kind of synchronization directly into your corporate culture and your engineering pipelines so it really sticks? First things first, you absolutely have to kill the innovation cop narrative. This is such a common failure pattern where the AI governance office is just viewed as this slow, bureaucratic department whose only job is to say no. Listen, when developers feel blocked by endless paper checklists, they're just going to secretly build unmonitored, highly risky shadow AI applications just to hit their business timelines. Governance has to genuinely support innovation, not just manage empty compliance paperwork.
The real solution here is to turn governance directly into code. Modern governance isn't a 50-page PDF checklist sitting on a shared drive. It is an automated, metric-driven control built right into the delivery pipeline. Think of a simple script that evaluates a model's projected business ROI right alongside its disparate impact ratio. If the ROI is sky high but it fails the fairness score, the code itself automatically blocks the deployment pipeline. Governance essentially becomes an automated execution shield. To actually put all this into practice today, here are 3 key takeaways for you. Number 1, formulate shared OKRs. Your engineering teams must be rewarded for both shipping on time and passing automated fairness metrics. Stop separating their incentives. Number 2, build a centralized AI use case registry. Make it a rule. No code is written until the risks are properly logged. And number 3, automate the delivery of your compliance artifacts. Extract things like data lineage and bias calculations straight from your code check-ins. That is how you keep the velocity high while staying incredibly safe. So I'll leave you with this final thought to really reflect on today. Take a hard look at your own enterprise AI initiatives. Are you building a fragile rocket ship that is practically destined to crash at the very first sign of market volatility? Or are you building a sluggish armored tank that's just going to get completely outpaced by your competitors? Remember, the entire point of having elite carbon ceramic brakes is so you can push that gas pedal to the absolute limit with total confidence. That wraps up this explainer on AI strategy versus governance. We've got a lot more to cover in this space, so keep learning, and I'll see you in the next one.
Hey everyone, and welcome to this explainer. Today, we're going to untangle the massive corporate confusion surrounding AI safety.
If you've ever felt like your engineering teams, your legal counsel, and your PR departments are just speaking completely different languages when it comes to launching AI, well, trust me, you are definitely not alone. It's a mess out there. But today, we're going to fix that. Here's our roadmap for today. We'll start with the AI Governance Challenge, then move to the 3 sheets of glass, look at some real-world governance collisions, talk about operationalizing the 3 layers, and finally, avoiding common AI traps. Let's just dive right in.
Section 1, the AI Governance Challenge. Before we unpack our core framework, we really have to recognize the reality of modern AI deployment. We are way past the experimental phase of machine learning. We are firmly in the era of strict accountability. So, where are we pulling our operational model from today? Well, we're taking it straight from Chapter 9 of the AI Governance and Responsible AI Extended Training course by Durga Analytics. And this thing is absolutely massive. It's a 500-chapter enterprise-grade course. This program is built specifically for self-paced learners and corporate cohorts, aiming for those high-level 650K tier AI leadership roles. It covers the whole spectrum: governance frameworks, global regulations like the EU AI Act, LLM governance, MLOps, risk audits, and it even gives teams enterprise-ready templates and capstones. But you know what? The most foundational lesson, the one your team absolutely must master before touching any of those advanced tools, relies on understanding 3 distinct forces that dictate corporate behavior. Moving to Section 2, the 3 sheets of glass. To build genuinely safe systems, every AI application has to pass through this master framework. It's like a giant filter made of 3 totally different layers. Let's break them down. Okay, picture an autonomous delivery drone. The first layer is ethics. This is the voluntary decision to write extra code that blurs out human faces and house windows in real time to protect privacy. You do it simply because it's the right thing to do. There's no central ethics police that's going to bust down your door if you build a model without empathy. The penalty here? Public shame, massive consumer boycotts, or your best engineers literally walking out the door. Ethics is your internal moral compass. Now for that exact same drone, compliance is a whole different ballgame. This is submitting your promised monthly maintenance checklists to a neighborhood association so you don't breach your delivery contract. Compliance lives and dies by the paperwork: ISO standards, model cards, audit trails. It explicitly answers the question, did we follow our internal playbook? And the penalty for failing compliance isn't necessarily a boycott. It's internal project freezes, people getting fired, or a nasty breach of contract. Then, finally, you hit regulation. This is the strict federal aviation law stating your drone cannot fly higher than 400 feet. This is the unyielding border, guys. Ignorance is never a legal defense here. Enforced by governments and state prosecutors, the penalties are devastating. We're talking millions in structural fines, criminal asset seizures, and immediate shutdowns. Regulation answers a very simple question: what are we legally forced to do? When you map all this out into a functional boundary matrix, the differences are literally night and day. Ethics asks, is it right? Compliance asks, is it documented? And regulation asks, is it legal? These are fundamentally different questions, and they're usually managed by completely different people. You've got the chief sustainability officer driving ethics, internal auditors checking compliance, and government judges enforcing the law. Which brings us to Section 3, real-world governance collisions. Here's the kicker. These 3 distinct layers, they almost never move together perfectly. In messy organizations, they run in isolated corporate bubbles. And when they don't align, well, disaster strikes. Let's look at what happens in the real world. First up, a major retail store perfectly met compliance. They filled out all their data storage forms and legally deployed facial recognition to catch shoplifters. But they secretly scanned millions of everyday innocent shoppers. That ethical failure sparked massive boycotts and actually forced local cities to write laws banning the tech entirely. On the flip side, look at ChatGPT back in early 2023. They had great internal safety guidelines, but they hit an unyielding regulatory wall in Italy regarding GDPR. The result? Instant shutdown. Because regulation always carries absolute veto power. All right, Section 4, operationalizing the 3 layers. So how do mature enterprises actually fix this? How do they stop running these disciplines in isolated bubbles? Because you can't just have lawyers looking at the law, data scientists staring at the code, and PR teams drafting ethics statements without talking to each other. You've got to merge them into a single automated operational workflow. Think of it like a layered pipeline architecture. A new AI system is proposed and immediately hits layer 1. Is it legally banned, like social scoring? If yes, terminate instantly. No way it's going forward. If it passes, it moves to layer 2, compliance checks. Does it have the required model cards? Hold the project if no. Passes again? Great, it hits layer 3 for ethical alignment to make sure it respects human dignity. And this translates directly into actual engineering realities. We're talking master governance gates coded right into Python that evaluate the AI asset across all 3 of those boundaries. A regulatory failure triggers a critical system exit. It literally crashes the build. A compliance failure triggers a hold, but an ethical warning routes the project to a human executive review board. True governance is embedding these exact checks directly inside your engineering infrastructure. Finally, Section 5, avoiding common AI traps. Because let's be real, even with the most brilliant automated pipelines, human oversight is absolutely mandatory. Python scripts can't negotiate corporate strategy. Let's run a quick boardroom simulation. Imagine a company, Apex Health, proposing an AI model that adjusts insurance premiums based on what people buy at the grocery store. The data team wants to scan loyalty cards to track fast food versus fresh produce purchases. The sales lead is practically jumping out of their chair. They're thrilled because it completely passes the regulation and compliance layers. But the chief medical officer, they slam on the brakes. They point out the horrific, devastating ethical failure of secretly penalizing poor families who simply can't afford organic food. So what do? To avoid the trap of assuming legal said it's fine, so we're safe, you have to categorize the conflict, map the reputational exposure, and engineer a transparent compromise. This is exactly what a chief AI governance officer does. They see the conflict stalls at the ethics layer. They map out the massive brand damage that would hit if the secret tracking leaked. And then they pivot. Instead of secret surveillance, they formulate a clean compromise. A completely transparent, voluntary opt-in wellness discount program. The customer explicitly chooses to share data to win gym discounts. Boom. The data pipeline stays clean, the law is satisfied, and the corporate ethical values remain totally intact. To wrap this up, let's quickly review the most common traps. Just because you filled out a compliance checklist does not guarantee your model is inherently unbiased, accurate, or globally safe. The legal said it's fine trap completely ignores that severe ethical backlashes can destroy your brand long before a government passes a law to stop you. Next, confounding paperwork with safety. This is assuming a completed spreadsheet means your AI performs well. Compliance tracks the process, right? It absolutely does not guarantee the actual performance of your model. And finally, treating global laws as identical blocks, that's a massive error. A model built for US guidelines will not automatically pass the European Union AI Act. So I'm going to leave you with this question to really think about. Is your AI deployment pipeline truly resilient across all 3 sheets of glass? Or are you just legally compliant while sitting around waiting for an ethical disaster? Understanding these distinct boundaries isn't just some academic exercise. It's literally the functional blueprint for enterprise survival in the age of AI. Take these lessons, go check your own pipelines, and start building automated protection today. Thanks for hanging out with me for this explainer.
Hey everyone, and welcome back to The Explainer. Today, we're diving deep into some absolute gold pulled straight from Chapter 10 of the AI Governance and Responsible AI 500 Chapter Extended Training course. Now, if you know this course, you know it's this massive enterprise-grade deep dive covering everything from regulations to ML ops. But today we're zeroing in on one absolutely massive corporate headache. How on earth do you take fuzzy, abstract AI ethics and turn them into hard, mathematical engineering controls? Well, the answer is the enterprise-grade Durga model, and we're going to master it right now.
Here is our quick roadmap for today. We'll start with the AI ethics bottleneck, talk about building the AI bank vault, break down the 7 Durga pillars, look at some real-world AI disasters, and finish up with hard-coding ethics into pipelines.
All right, Section 1, the AI ethics bottleneck. Abstract ethics versus concrete code. So picture this, because we see this massive disconnect in the corporate world all the time. On one side of the building, you've got the legal and compliance teams handing down these beautifully formatted 100-page PDFs just packed with feel-good buzzwords like human centricity and equity. Sounds great, right? But then, on the other side, you've got a developer staring at a blank code repository, scratching their head, asking, okay, but how exactly do I write a Python function for human centricity? It's wild. Without a real structural bridge, all those ethics are just an empty PR exercise. Because let's be real, a PDF has literally never stopped a rogue algorithm.
Which brings us nicely to Section 2, building the AI bank vaults and the Durga model metaphor.
Think about it like a giant physical bank vault. You wouldn't just slap a cheap padlock on the front door and call it secure, right? No way. You just biometric locks to control access, reinforced concrete walls to withstand an earthquake, the whole shebang. Well, the Durga Vault system applies that exact same multi-layered security matrix directly to your algorithms. It completely replaces good intentions with a rock-solid auditable architecture.
Let's move right into Section 3, the 7 Durga pillars, taking us from theory to operational math.
Okay, so Pillar 1 acts as the vault's primary lock. It's all about fairness and algorithmic justice. This isn't a suggestion. It actually forces your engineering teams to code statistical parity checks directly into their validation scripts. Basically, it uses automated math to catch and neutralize human bias before a model ever sees the light of day.
And this right here is where the magic happens. The Enterprise Control Registry proves that abstract ideas have to become hard numbers. Fairness isn't just a word anymore. It translates directly into a disparate impact ratio that must stay between 0.80 and 1.25. Boom. Reliability, that's measured by an adversarial draw percentage, making sure accuracy loss under heavy stress stays under 5%. And privacy uses an epsilon score to guarantee data leakage stays below a strict 1.0 threshold. This is how you actually govern AI.
The remaining pillars? They demand total operational rigor. Pillar 4, transparency, forces the black box open by mandating explainability scorecards. Pillar 5, human agency, demands absolute human control. We're talking literal infrastructure kill switches. Pillar 6, security, requires independent semantic guardrails to scan for things like prompt injections. And Pillar 7, sustainability, actually automates the tracking of your compute carbon emissions so you know exactly what your footprint is. Now, what happens when you ignore all this? Let's look at Section 4, real-world AI disasters. 20 times. Let that sink in for a second. In one massive credit limit equity scandal detailed in Chapter 10, an automated machine learning model inexplicably granted husbands credit lines 20 times higher than their wives. And get this, they had identical financial histories, joint tax filings, the exact same income profiles. It was a complete, catastrophic failure of Pillar 1, fairness.
And it gets worse. Because this enterprise totally neglected Pillar 4 transparency tools, their customer service reps were completely stranded. They literally had to tell furious customers,
The computer calculated the score. It's a black box. We can't explain the math. I mean, can you imagine? Predictably, this triggered massive federal investigations and a global PR nightmare. And the financial hit for ignoring these pillars? Try $6.5 million. That's the severe federal fine a national healthcare provider was slapped with after an absolutely catastrophic automated data breach.
So how exactly does a $6.5 million disaster happen? Well, it was a classic healthcare agent loophole. The developers bypassed centralized security gateways, just trying to speed up development velocity. But this allowed an external hacker to use an indirect prompt injection. Basically, they hid text strings inside a fake medical invoice file. When the AI read the invoice, the hidden text commanded it to override its own rules. Because they failed at Pillar 3 and Pillar 6, meaning they had no data scrubbing proxy and zero input guardrails, that AI leaked 100 real patient medical records straight onto the public internet. Just a total nightmare.
All right, final section. Section 5. Hard-coding ethics into pipelines with a governed CI/CD architecture.
To stop those disasters, we have to build a governed CI/CD delivery architecture. Under this setup, every single time code is committed, it has to physically survive a gauntlet of automated gates. First, the fairness check evaluates the ratio. Then, a resilience check literally throws corrupted data at it to ensure the model doesn't fail silently under pressure. Next, privacy proxies and security guardrails kick in. Only after all these automated checks pass do you get the cryptographic sign-off that legally unlocks live production.
And honestly, this is the ultimate payoff. What we're looking at here is a literal Python script straight from the course material acting as an automated system gate. It is programmed to intentionally crash the build if the fairness ratio drops below 0.80 or if it spots a privacy leak. It takes abstract ethics and literally turns them into an automated kill switch that stops a bad model cold before it ever launches.
Because listen, if you don't implement this exact type of hard code, you're suffering from what we call the paper pillars illusion. That's when a company spends thousands designing a gorgeous, glossy brochure about their deep commitment to ethics, but fails to write a single line of software to actually back it up. It's treating corporate safety as just a cheap public relations stunt.
Ultimately, Chapter 10 of the course reminds us of one unavoidable truth. Accountability always resolves to humans, right? No matter how autonomous or advanced an AI agent seems, the legal and financial liability always lands squarely on the humans who built and deployed it.
So I want to leave you with this absolutely critical question. If your most advanced AI model was manipulated by a hidden prompt injection today, do you actually have the hard-coded kill switch required to stop it? Or do you just have a PDF of good intentions? Ask yourself, have you actually built the vault? Thanks so much for joining me for this explainer, and I'll catch you in the next one.
Welcome to this explainer. Today, we're taking a really fascinating look at the actual human engine that drives AI governance. We're drawing this straight from Chapter 11 of the Durga Analytics Enterprise-Grade AI Governance and Responsible AI course. It's this massive 500-chapter training program covering everything from regulatory frameworks right down to MLOps. But right now, we're zooming in on one of the absolute most critical elements they teach, the rigid human chain of command you absolutely need to operate complex AI machinery safely.
So let's dive right in with a pretty catastrophic real-world disaster. Just imagine an unmonitored, automated trading model going completely rogue. In a recent case study, a reinforcement learning model hit some unprecedented market conditions, basically got mathematically confused and just started rapidly shorting currency pairs. It drained $180 million of a firm's capital in exactly 72 minutes. I mean, wow. That is literal corporate extinction happening in just over an hour.
So how does something like that even happen? Well, it happened because an engineering manager decided to just bypass the governance gate. Their excuse? The code was clean, and they didn't have time to wait for risk officers to catch up. Because they skipped that planning gate,
Nobody had assigned explicit decision rights for an emergency kill switch. So you've got this on-call server engineer watching the capital literally drain away, but they're too terrified to unplug the server without an executive's permission. It just goes to show that technical brilliance is completely useless and honestly downright dangerous without a structured chain of command.
All right, here's our roadmap to solve this massive vulnerability. First, the AI blame game. Second, meet the RACI matrix. Third, the production sign-off gate. Fourth, the emergency kill switch. Fifth, separation of duties. And finally, enterprise execution best practices.
Section 1. The AI blame game. Who is actually responsible? You know, when traditional software breaks, it's usually pretty obvious who to call. But AI is a whole different beast. When an AI system fails silently in production, like, say, slowly starting to accidentally reject minority loan applicants, the human chain of command usually just collapses into this toxic circle of finger-pointing. The data scientist blames the data engineer. The engineer blames compliance. Compliance blames the math. It's a mess. Think of an aircraft carrier to solve this. Your data scientists and engineers, they're the specialist pilots. They fly the jet, they write the code. But you absolutely must have a designated business unit executive. They're the ship's captain. They might not write a single line of Python, but they hold ultimate, absolute operational and legal liability for that vessel.
Moving on to Section 2. Meet the RACI matrix. Dividing up those corporate duties.
To actually fix this blame game, we use a formal framework tailored specifically for the unique quirks of machine learning life cycles. It's called the RACI model. It clearly divides corporate duties into responsible, accountable, consulted, and informed. The responsible folks are your hands-on builders, like your MLOps engineers. The consulted ones are your advisors, think data privacy officers, whose input is 100% mandatory. Informed are your macro-level observers, like the CEO. But here is the absolutely crucial rule for the accountable role. Accountability can never, ever be shared. You can have 10 developers responsible for the code, sure, but you must have exactly one executive accountable for the asset. If the AI breaks a law, that single manager cannot just pass the buck downstream.
Section 3. The production sign-off gate. Let's look at the deployment gateway.
Taking these roles into the real world starts at the absolute highest stakes workflow of all, the deployment gateway. Listen, a model cannot simply slide into production just because some engineer finished a coding sprint. No way. The pipeline essentially physically locks the container. It requires an explicit digital multi-key authorization sequence. Think of it like a launch sequence. You need the lead data scientist to attest to the technical soundness, the data privacy officer to attest to compliance, and that accountable business executive to accept the liability. Only when all those keys are turned does the container actually unlock and deploy.
Which brings us to Section 4, the emergency kill switch. What happens when things malfunction in the middle of the night?
Because, let's be real, no model is perfect. What happens when a live AI just starts glitching out at 2 a.m.? Imagine this scenario at a company called Global Retail Corp. They use this generative AI assistant, let's call it Talent Scout Bot, to chat with warehouse applicants. Well, on a random Thursday morning, the bot falls victim to a hidden prompt injection attack, tucked away inside an applicant's resume. And suddenly, out of nowhere, it starts offering thousands of applicants free luxury housing and $150 an hour minimum wage. So what do?
Well, your organization needs to have an unambiguous, code-enforced execution chain ready to go. A 4-step emergency kill switch runbook. Step 1. The telemetry alert detects the anomaly. Step 2. Instant SRE intervention. Step 3. Executive escalation. And Step 4. The forensic lock to isolate the container. This whole sequence has to act instantly. We're talking zero hesitation. You definitely can't wait around to convene a corporate board meeting.
Let's trace how that actually plays out in our RACI framework. An HR coordinator spots the crazy wage offers and pings the on-call site reliability engineer.
Now that SRE exercises their explicit pre-authorized right to flip the bot into maintenance mode right then and there. They don't ask for permission, they just stop the bleeding. The system then automatically pages that accountable VP of HR, while the responsible data scientists lock down the inference logs to isolate that prompt injection breach. It's safe, it's fast, and it is highly structured.
Section 5. Separation of duties. Establishing strict team boundaries.
Now, this kind of swift, safe response, it's really only possible if you have strict boundaries between your teams. There's a fantastic real-world example from Goldman Sachs involving an automated credit underwriting algorithm. They protect themselves by completely separating the development squad, the team whose job is to design the model and optimize for profits, from an independent validation squad. That validation group actually reports to the chief risk officer, not the business unit. They don't write the code. Their one and only job is to audit, stress test, and wield ultimate veto power. Separating the team that's chasing profit from the team that's policing safety is exactly what insulates the institution from massive regulatory disasters.
And finally, Section 6. Enterprise Execution Best Practices. Turning this into daily habits.
To make sure your enterprise doesn't end up facing crazy regulatory penalties or, financial extinction, we have to distill these governance frameworks into daily execution habits. Basically, you've got to avoid some really common traps. First up is the shadow accountability trap. Never ever push accountability down to a junior contractor or an engineer just because they were the ones typing the code. Second, avoid the committee paralysis loop. If you require dozens of managers to verbally sign off on every minor change, your development velocity is going to drop to zero, and your engineers will just start building shadow AI in secret. And lastly, watch out for the untested kill switch blind spot. Having an emergency switch documented on a piece of paper is completely useless if pulling it in real life crashes your entire transaction engine because you never actually bothered to technically test it.
So, wrapping up, here are the absolute key takeaways from this explainer. First, accountability is indivisible. It cannot be shared, and the buck has to stop with one executive. Second, a structural separation of duties is your best legal shield. Having independent validation teams is just non-negotiable. And third, your emergency kill switch requires pre-authorization. Your frontline engineers must possess the documented, unquestionable right to pull the plug instantly when a safety budget is breached.
I want to leave you with this final, really critical thought today. Take a hard look at your own organization. If disaster strikes your highest risk AI systems tonight, does your team know exactly who holds the authority to stop it? Think about it. If that answer isn't immediately obvious to every single engineer on the floor, it might just be time to rethink your human engine of governance. Thanks for tuning in to this explainer, and keep asking those tough questions.
All right, welcome to this explainer. Today, we're pulling some absolutely crucial insights straight from Chapter 12 of the massive AI Governance and Responsible AI training course. It's a huge 500-chapter enterprise-grade program that covers everything from LLM governance and ML ops to audits and industry case studies. But for our purposes right now, we're going to strip away all that complex mathematical jargon and show you exactly how enterprise AI systems break down, drift, and glitch in the real world.
So, let's kick things off with what is arguably the most terrifying question for modern enterprise risk officers right now. What actually happens when these advanced multi-million-dollar predictive engines just fail? Because unlike the software we're all used to, AI doesn't scream when it breaks. It is totally silent. There's a stark contrast between traditional software and AI models. Think about it. If a developer misses a single semicolon in a traditional banking app, the whole thing crashes loudly, right? You get obvious syntax errors, error screens pop up, alarms go off. But AI models, they fail silently. The user interface remains absolutely spotless. The database just keeps processing transactions flawlessly like nothing is wrong at all. It's wild because an AI can output fluid, perfectly natural language or crisp numbers with a supposed 99% statistical confidence, all while the actual math inside the model has gone completely haywire. It's literally generating incorrect, biased, or financially devastating automated choices, and no one realizes it until days, weeks, or even months later. No alarms, just a quiet catastrophe. Okay, let's make this concrete. Picture an autonomous greenhouse. You've got an AI running a massive multi-million-dollar agricultural facility. Suddenly, a simple cloud of dust settles on a light sensor. The AI reads this, thinks it's pitch dark outside, assumes the plants are freezing, and immediately blasts the heating lamps. Well, that dries out the soil, which then triggers the water valves. The resulting humidity creates condensation on that same sensor, making it look even darker to the AI. So what does it do? It turns the greenhouse into a boiling oven, all while the central dashboard is reporting perfectly stable green light operations. Crazy, right? And that kind of cascade leads us directly into the first of 5 specific failure modes we're covering today, the data feedback loop. This happens when a deployed model effectively starts consuming its own historical outputs as fresh training material. It creates this self-reinforcing algorithmic echo chamber that completely distorts reality. Let's look at how this plays out in the real world, say in corporate HR. Imagine a recruiting AI that initially, maybe just slightly, favors candidates from 2 specific universities. Recruiters blindly follow the AI's rankings, meaning they only interview people from those schools. Then, at the end of the year, that new hiring data, which now only contains those specific profiles, is fed right back into the system's training queue. The model's initial bias is magnified to 1,000% certainty. You end up accidentally locking out exceptional talent, and the AI thinks it's doing a perfect job. Moving on to bug number 2, overfitting, or as it's sometimes called, the memorization trap. Think of a quantitative hedge fund trading model. It achieves this beautiful 99% accuracy in the lab simply because it memorized the exact noise and micro fluctuations of the stock market between, say, 2018 and 2022. But the second you deploy it live and it encounters a fresh, unexpected economic environment, its performance collapses instantly. We're talking millions lost in a blink because it didn't learn the market. It just memorized a specific slice of the past. All right, third up is target leakage. This one's a bit of a hidden mathematical cheat code. Here, the AI isn't actually learning a complex pattern at all. It's just finding an invalid database shortcut. For example, imagine an AI tasked with predicting emergency room sepsis. But instead of analyzing complex symptoms, it figures out a shortcut. It just checks if a patient has already been assigned an ICU bed number. In a live production environment, a brand new patient walking through the door doesn't have an ICU number yet, so the model becomes physically impossible to use. Now, closely related to that algorithmic blind spot is the cold start problem. This one frequently plagues entertainment streaming platforms. Imagine millions of new users signing up on launch day. The AI has absolutely zero clickstream history or transaction records for any of them. Without that statistical baseline, it panics and serves up completely random, volatile, and frustrating content recommendations. And what happens? Instant subscriber churn. And that brings us to our 5th bug, cascading system errors. This is the domino effect. Modern enterprise architectures chain multiple models together, right? Model A scans social media trends, Model B assesses inventory, and Model C issues the purchase orders. Well, what if there's a tiny unmonitored 2% mathematical drift in Model A, maybe from a viral internet joke about clown suits? That tiny error amplifies exponentially as it moves down the grid. Model C executes the logic to its extreme endpoint, and boom. You suddenly own millions of dollars in useless, uncancelable clown suit inventory. Now, I really want to stress that these aren't just theoretical thought experiments. Take Amazon's infamous 2014 AI recruiting project. They trained an AI to rate developer resumes using a 10-year historical benchmark. But because the tech industry was historically male-dominated, the AI fell victim to severe overfitting and a massive data feedback loop. It actually concluded that being male was a prerequisite for success, and it began silently penalizing resumes that included explicitly gendered phrases, like women's college. Because here's the hard truth we all have to face. Models generalize correlations, not justice. And AI simply cannot understand human fairness. If your historical datasets mirror an unequal past, your unaudited AI pipelines are going to automate that past inequality at machine speed. For Amazon, this wasn't just a glitch. It became a massive corporate liability that they had to completely dismantle. Let's pivot to another massive real-world failure, this time with Unity software back in 2022. Unity relies on a machine learning tool called Pinpointer to target high-paying mobile game players. Well, an engineering glitch allowed corrupted downstream ad tracking data to leak straight back into the main training inputs. It was a textbook worst-case scenario combo of target leakage and cascading system errors. Because they didn't have the right runtime observability gates in place, the system ran smoothly at scale for weeks, all while generating completely broken business decisions. And the financial toll? It was staggering. This completely silent failure wiped out an unbelievable $110 million in direct quarterly revenue. And, as you'd expect, the market consequences cascaded just as fast. The second this algorithmic failure was exposed to the public, Unity's stock plummeted by 37% in a single trading day. That completely erased billions in market valuation and triggered some incredibly intense shareholder lawsuits. So, how do we actually manage all of this? Let's walk through a practical enterprise scenario with a fictional company, Global Foods Logistics. They use a highly efficient AI bot to calculate their grocery inventory. But then, a sudden global port strike causes a 48-hour localized shortage of avocados, which triples the retail price. Operating in a total governance vacuum, their bot completely overfits on this highly localized spike. The model misinterprets this temporary 48-hour supply chain glitch as a permanent, exponential surge in consumer demand. So it executes its logic to the extreme endpoint, automatically generating uncancelable legal purchase contracts for 800 tons of fresh avocados. I mean, we're talking about an almost catastrophic overfitting cascade that would ruin the quarter. Right, so this is exactly where the 5-step governance for mediation pipeline comes in to save the day. Step 1, automated MLOps triangulates the anomaly immediately. Step 2, site reliability engineers instantly activate a conservative backup challenger model. Step 3, the incident is escalated straight to the governance board. Step 4, the corrupted data gets cleansed and retrained. And finally, Step 5, you require an independent compliance sign-off before that model ever sees deployment again. Protecting your enterprise requires actual, hard-coded runtime interceptors. You need strict statistical ingestion guards that automatically block data payloads the second they exceed safe historical variance limits. And you absolutely must mandate the continuous deployment of backup challenger models. You need that safe fallback the exact moment your primary telemetry starts to drift. Now, as you look at this mapping, I want to highlight something absolutely crucial. Catching these specific engineering bugs isn't just an IT headache anymore. It's a core compliance mandate. Fixing data feedback loops? That aligns directly with Article 15 of the EU AI Act. Mitigating those cascading errors maps straight to the NIST Risk Management Framework's Manage function. Strong governance is exactly how you operationalize technical safety. So, as we wrap up this explainer, I want to leave you with a final thought to really chew on as you look at your own corporate architecture today. Are you truly monitoring your AI pipelines for silent drift, target leakage, and cascading errors? Or are you just waiting for the disaster to finally hit the dashboard? Thanks so much for joining me today, and remember, always keep questioning the math behind the machine.
Welcome back to The Explainer. Today, we are stepping right out of the theoretical engineering lab and straight into the high-stakes corporate boardroom. We're actually pulling key insights directly from Chapter 13 of the AI Governance and Responsible AI 500 Chapter Extended Training course. If you aren't familiar with it, it's this massive, enterprise-grade curriculum designed for self-paced learners and corporate cohorts. It covers the whole shebang: governance frameworks, regulations, risk, LLM governance, MLOps, audits, templates, capstones, you name it. But today, we're zoning in on their industry case studies to conduct a forensic autopsy on some very real, highly public corporate AI meltdowns. We aren't just looking at what went wrong. We want to trace exactly how these failures slipped through the cracks to cause absolute chaos.
So let me ask you this, and it totally bypasses the usual corporate jargon about digital transformation or synergy. Because when an algorithm operates inside a corporate governance vacuum, that supposed efficiency can turn into a high-speed vehicle for financial destruction in a heartbeat. The real question is, what exactly happens when a multi-billion-dollar automated engine completely outruns its safety infrastructure?
To wrap our heads around this, let's use a metaphor. Picture a massive logistics corporation that buys a fleet of ultra-heavy, fully automated cargo trucks to move freight across winding mountain passes. Now, executive leadership demands these trucks hit 90 miles per hour to maximize profit. The engineering team, who are only rewarded for speed, never bothers to install thermal cooling sensors on the mechanical brakes. Everything looks totally fine on the flat factory floor, right? But as that heavy truck accelerates down a steep mountain pass, the immense friction causes the brakes to overheat and literally silently melt away. The dashboard shows everything is perfectly normal, right up until the truck hits a sharp turn, completely fails to slow down, and crashes right through the guardrails. Ungoverned corporate AI? It's that exact brake failure.
Okay, let's dive into this. To get genuine educational value from these disasters, rather than just shrugging and saying, mistakes were made, we apply an incident analysis matrix. We're going to systematically dissect each crisis across 5 forensic vectors: the background, the technical trigger, the governance blind spot, the total material impact, and finally, the operational lesson. Let's apply this to our first crash.
Our first forensic autopsy takes us back to 2018. Digital real estate titan Zillow launched Zillow Offers. This was an incredibly aggressive corporate venture to dominate the iBuying sector. The strategy was fully automated. A highly complex machine learning algorithm evaluated properties, automatically generated cash purchase offers to homeowners, triggered light physical renovations, and then flipped the houses on the open market for a profit. The ultimate goal here was pure speed and massive volume.
But then came the technical trigger. The algorithm was heavily optimized on years of very stable historical housing transactions. But in late 2020, the global pandemic hit. Remote work shifts caused highly volatile, unpredictable pricing fluctuations in real estate. The underlying math broke down entirely. In the industry, this is called concept drift. The model basically misinterpreted short-term pandemic buying spikes as a permanent, unstoppable upward trend, and it began silently overbidding on thousands of houses in declining neighborhoods.
Now, you might be wondering, why didn't anyone stop it? Well, here is the fatal governance blind spot. Executive leadership was so hyper-focused on beating competitors and scaling volume that management intentionally widened the model's automated authority boundaries. They literally bypassed the brakes for speed. They reduced human-in-the-loop validation. There were absolutely zero automated data drift triggers in the engineering pipeline. Even when local human real estate agents were screaming that the automated offers were absurdly high, the corporate system just let the transactions execute instantly without flagging any risk tickets.
The impact? An existential balance sheet collapse. Zillow was left holding tens of thousands of wildly overpriced homes that it couldn't sell. They had to execute a massive $500 million asset write-down. They abruptly shut down the entire Zillow Offers business unit overnight, which resulted in the summary termination of 25% of their global workforce. Almost 2,000 people lost their jobs, all because they lacked real-time drift sensors and strict transactional limits.
let's shift our focus to an even more sobering historical case: the Dutch childcare benefits scandal. The Dutch Tax and Customs Administration deployed a self-learning risk classification algorithm. Its job was to automatically scan millions of state childcare benefit applications. The goal was to assign a predictive probability score, essentially ranking the likelihood that an applicant was committing systemic welfare fraud.
The technical trigger here was profound algorithmic bias. The model was trained on historical records containing deep socioeconomic biases. It actually overfit onto patterns like having a foreign-sounding last name or dual nationality status, treating those things as mathematical indicators of criminal intent. But what made it worse was a phenomenon known as automation bias. Government caseworkers developed a dangerous tendency to treat the algorithm's biased risk scores as an absolute, indisputable oracle, just rubber-stamping life-altering enforcement actions without ever reviewing the underlying evidence.
The governance blind spots were absolute. There was a complete and total breakdown of human-in-the-loop oversight. Furthermore, the system design featured zero mechanisms for affected citizens to request an explanation of the model's logic or even challenge the automated decision. It was a black box that created a vicious target feedback loop. It flagged minority families for intense audits. Those intense audits naturally turned up minor clerical errors, which were then fed back into the model as proven fraud, completely validating the biased math.
The human toll was absolutely staggering. Over 26,000 innocent families were driven into financial ruin. Legitimate childcare allowances were suddenly cut off, and immediate retroactive repayments of tens of thousands of euros were demanded. Families lost their homes, their jobs, and in some tragic cases, custody of their children. This artificial fraud flag led to the collapse and mass resignation of the entire Dutch government cabinet in January 2021, and the state was forced to allocate over 500 million euros in direct restitution.
Our final historical case study brings us to aviation, the Boeing 737 MAX MCAS failure. To compete rapidly in the market, Boeing engineered the 737 MAX with larger engines positioned further forward. This physically altered the aerodynamics, creating a natural tendency for the plane's nose to pitch upward. To correct this automatically, and crucially to do it without requiring expensive, time-consuming pilot simulator retraining, Boeing installed an automated flight control software subsystem known as MCAS.
The technical trigger here was a textbook, fatal single point of failure. The MCAS software relied entirely on input from just one physical sensor probe mounted on the outside of the fuselage. During the tragic operational flights, this single sensor malfunctioned. It started passing a corrupted, hyperinflated angle of attack data stream into the automated software loop. The algorithm misread this corrupted input as a catastrophic emergency stall condition.
Now, what's really terrifying about this is the catastrophic governance blind spot, a complete violation of human autonomy. To streamline regulatory approvals, Boeing actually omitted detailed explanations of MCAS from the pilot manuals. Worse, the software was programmed in a recursive loop. Every single time a human pilot manually pulled back to stabilize the aircraft, the automated algorithm initiated a fresh, even more aggressive nose-down command just 5 seconds later. It completely locked out and physically exhausted the human flight crew.
The material impact is one of modern history's greatest industrial tragedies. The algorithmic failure claimed the lives of 346 innocent passengers and crew members across 2 horrific crashes. The entire global fleet was grounded for 20 months. Boeing incurred over $20 billion in direct operational losses, legal payouts, and fines, and suffered a permanent, devastating erosion of its corporate safety reputation.
Okay, take a breath. We've seen exactly what happens when the brakes fail. Now let's pivot to how we actually prevent this. We are going to step into a practical, hands-on enterprise simulation from that AI governance training course I mentioned earlier. Let's run through a scenario and build out a proper incident containment playbook.
Welcome to the Apex Lend Financial Corp simulation. Apex Lend processes 100,000 retail loan applications every day using an automated ML underwriting platform. At 9:15 a.m., an upstream credit bureau experiences a tiny formatting glitch. They pass empty values in the debt history column as the literal text string NULL instead of just a standard blank field. Well, the algorithm's text parsing layer misinterprets the word null as a numerical value of zero debt. The system goes totally wild at machine speed. In just 45 minutes, it auto-issues legal loan contracts and wires a total of $14 million in cash to high-risk, unverified accounts, and it does all this while reporting a 100% success rate to the executive team.
So here is how a governed response operates in that scenario. Phase 1, 0 to 5 minutes. The automated observability dashboard detects the cash dispersal rate is 800% over budget. Bam, an alert fires. An empowered site reliability engineer hits the technical kill switch, instantly pulling the model out of the network path and routing traffic to a safe, conservative challenger model. Phase 2, 5 to 30 minutes. The incident is immediately logged into the AI governance platform, alerting the chief risk officer. Legal is mobilized to issue freeze hold notices to clearinghouse banks to stop that $14 million in transit. Phase 3 is post-incident. Data scientists isolate the container, map the failure path, find that text parsing error, and patch the pipeline.
And this concept brilliantly illustrates what installing the brakes actually looks like in practice. For instance, you could use a Python snippet acting as an automated dynamic anomaly kill switch interceptor. It sits directly behind the production model's inference loop. If an unauthorized capital loss threshold is breached, it programmatically cuts power to the system, protecting the corporate treasury at absolute machine speed.
So the absolute crucial point you must take away from all of this is that the old excuse, "the computer did it," is completely dead. Global legal and regulatory precedents have firmly established that an enterprise holds strict and absolute liability for the real-world outputs, representations, and financial errors executed by its automated software engines. You simply cannot blame the black box anymore.
Which leaves us with one final, very urgent thought. As we've seen today, ungoverned AI isn't just a quirky IT problem. It is a massive existential business risk. So I leave you with this. If your organization is rapidly deploying AI to chase efficiency and market share, do you actually know where your operational brakes are? Or are your safety protocols just a paper shuffling exercise waiting for the inevitable crash? Thanks so much for joining me on this forensic dive, and keep asking the hard questions.
Welcome to This Explainer. Today, we're diving into something that literally keeps corporate executives up at night: the severe, real-world consequences of poor AI governance. We're actually drawing our insights straight from Chapter 14 of Durga Analytics' massive 500-chapter extended training course. It's this incredibly comprehensive enterprise-grade curriculum covering everything from global regulations to ML ops and industry case studies. If you've ever thought of compliance as, just a boring checkbox, well, you're in for a massive wake-up call today. We're going to see exactly what happens when probabilistic machine learning systems fail in the wild, and trust me, the financial and operational penalties are staggering.
So let's kick things off by challenging a really dangerous corporate fallacy. You know how it is, right? Project timelines get super tight, and managers are often tempted to look at AI governance as this slow, bureaucratic luxury. The logic usually goes something like, hey, let's just skip the data provenance checks and fairness audits for now so we can actually hit our quarterly launch target. We'll just patch the code and slap on the guardrails later. But here's the reality. In modern enterprise software, skipping governance doesn't save you a dime or a minute. It's really just borrowing capital from the future at a completely hyperinflationary interest rate.
To really wrap our heads around this, imagine a massive chemical manufacturing plant. They've just built this cutting-edge factory right next to a major river. Now, to maximize those short-term profit margins and speed up production,
Management makes a call to skip installing expensive water filtration systems. Instead, they just dump their raw, untreated chemical byproducts straight into the river to hit their targets. Sure, they save, say, 50 grand up front. Looks great for this quarter's bonus, right? But what on earth happens when the environmental protection agencies actually find out?
Well, the fallout is absolute devastation. The government doesn't just issue a gentle warning or politely ask them to stop. No way. They levy an immediate fine that's hundreds of times larger than whatever money was saved. They declare the entire site a toxic hazard, seize the physical property, and literally force the company to bulldoze the multi-million-dollar facility. And to top it off, the board of directors gets sued by shareholders for gross negligence. Now, skipping AI compliance testing triggers this exact same environmental cleanup disaster just inside your digital ecosystem. That unmonitored, biased model output, that is your toxic byproduct.
Moving on to Section 1, the 4 pillars of failure.
Let's break down these 4 explicit damage vectors. These pillars are the devastating legal, financial, and operational penalties that smack an enterprise when ungoverned systems fail in production. We're talking hard regulatory penalties and fines, algorithmic disgorgement, which we'll get into in a second, executive personal liability, where leaders are literally sued for failing their duty of oversight, and finally, operational degradation. Trying to manually clean up a broken system while under the microscope of regulatory scrutiny, that often costs 10 to 50 times more than just embedding governance from day one.
Let's zoom in on that first pillar, regulatory penalties. The sheer scale of these fines is, frankly, astronomical. Take the EU AI Act, for example. Deploying a prohibited AI practice under this act carries administrative fines of up to 35 million euros, or 7% of a company's total global annual turnover, and it's whichever is higher. Oh, and because of extraterritorial jurisdiction, this applies to any enterprise whose model impacts EU citizens. So even if your servers and your entire engineering team are sitting entirely in the United States, you are still very much on the hook.
Okay, Section 2, the digital death penalty.
Beyond the massive fines, the operational reality of something called algorithmic disgorgement is absolutely terrifying. Here's what it means. If a regulator determines you trained an AI model using deceptively obtained or biased data, they don't just ask you to casually delete the database. Deep learning models absorb statistical correlations directly into their internal mathematical weights, right? So because that contaminated data is structurally embedded, the entire compiled asset becomes legally radioactive. Regulators will force you to completely destroy the trained models, the weights, the whole shebang. Years of engineering, millions in compute capital, and your best competitive features are legally vaporized from your balance sheet in an instant.
And we are already seeing this happen in the real world. Take WW International, the company formerly known as Weight Watchers. They acquired a youth wellness app, but collected children's data without getting rigorous parental consent. The FTC stepped in, slammed them with a $1.5 million fine in order to complete algorithmic disgorgement. All those proprietary health prediction assets, totally destroyed. Or look at Rite Aid. They deployed a biased facial recognition system to spot shoplifters, but it consistently generated false positives for minority and female shoppers, leading to innocent customers being falsely accused. The penalty there? The FTC flatly banned them from using facial recognition for 5 years and forced the total demolition of their multi-million-dollar server and camera architecture. Just brutal.
So how do we handle this? Let's get into Section 3, Navigating a Regulatory Crisis. Let's walk through a practical scenario straight from the Durga Analytics training. Picture a fictional company, FinVantage Lending Global, running this high-velocity credit scoring model called LendFast AI. The engineering group decided to rush the launch and completely bypassed the central AI governance office. Well, post-deployment, the model develops severe silent concept drift. It starts reducing approved credit limits by 65% for qualified female applicants. Eventually, a federal regulator detects the systemic bias and hits the bank with a formal subpoena.
Now, when that regulator comes knocking, panic is absolutely not a strategy. The enterprise has to immediately execute a crisis action plan. ideally led by the Chief AI Governance Officer. This is exactly where having a structured response architecture can literally save the company.
This mitigation plan unfolds in 3 crucial phases. Phase 1, activate the fallback control. Within 15 minutes, you need to pull that drifting model out of runtime and redirect 100% of the traffic to a safe, conservative, rule-based challenger model. Next up, Phase 2, compile your audit trail evidence. You have to generate an unalterable forensic history showing the exact model hashes and daily drift metrics. Finally, Phase 3, present a remediation blueprint to the regulator. You show them exactly how you are going to integrate mathematical checks, like the 4/4 fairness rule, into your deployment gates. By showing absolute visibility and instant containment, you can transform a catastrophic disgorgement threat into a manageable compliance correction.
But listen, this mitigation isn't just legal theory. It requires deep, hard engineering reality. Imagine an automated dynamic data compliance enforcer written in Python. It literally sits inside your pipeline and evaluates the legal readiness of a dataset before executing a model training run. If the verified consumer consent ratio drops below that 100% legal baseline, or if it detects any unmasked personally identifiable information, the script throws an exit code 1. It instantly crashes the automated build runner. Basically, it terminates the training engine before you can ever accidentally create one of those radioactive assets.
Which brings us to Section 4, the ultimate governance roadmap.
Crisis containment is super important, sure, but to truly insulate a company from terminal asset destruction, organizations have to evolve. You got to move away from emergency response and manual paper compliance checkers and move toward a proactive architecture. That means embedding automated governance as code hooks directly into your CI/CD pipelines right from day one. You force the calculation of fairness metrics on every single build iteration, and you generate immutable audit trails for every inference.
Making that transition from chaos to architecture is exactly what is mapped out in the Durga Analytics course we've been referencing today. What we've covered here is honestly just a tiny glimpse into their massive 500-chapter masterclass.
This enterprise-grade curriculum really bridges the gap. It translates responsible AI principles into tangible operational controls, covering global regulations like the EU AI Act and NIST, LLM and prompt governance, model lifecycle controls, hands-on tooling labs, and real-world incident playbooks. It literally gives your management cohorts the ultimate blueprint to measure and enforce long-term governance success.
And here is why this matters so much for you personally. Mastering these structural stages doesn't just protect corporate balance sheets, it actively mints the next generation of highly sought-after professionals. Seriously, AI governance leadership roles are currently commanding compensation packages up to $650,000. The market is just desperate for people who can bridge that complex gap between hardcore engineering pipelines and strict global regulatory mandates.
So as you look at your own organization's engineering pipelines, I want to leave you with a critical question to chew on. Ask yourself, are you building sustainable, governed innovation? Or are you simply borrowing capital from the future at a hyperinflationary rate, just waiting for a regulator to issue an algorithmic disgorgement order? The choice between building a premium asset and a radioactive liability is made in exactly how you govern your code today. Thanks so much for joining me on this explainer, and I really hope this sparks some serious conversations with your data and legal teams.
Welcome to this explainer. So, today we are diving headfirst into a massive challenge that is quite literally keeping executives up at night. How in the world do enterprises scale their artificial intelligence safely, without completely killing their speed of innovation? Well, it's time to move past all the theory and look at the exact structural frameworks that are actually being used right now to evaluate corporate AI safety.
How safe are our AI models? It sounds like a simple question, right? But this is exactly what a brand new Chief AI Governance Officer or Risk Director asks on day one. And honestly, almost every single time asking that question uncovers a terrifying lack of visibility. There's no magic dashboard,
No unified metric, just this vast, uncharted landscape of deployed models running wild. Because when leadership actually asks how safe things are, everyone just points fingers. The engineering teams will proudly tell you, hey, our models are incredibly accurate. Legal chimes in with, don't worry, we review incoming vendor contracts eventually. And the cybersecurity folks, they confidently state that the firewalls are holding up perfectly. But here's the big problem. These are all isolated, totally subjective answers. They completely failed to measure actual structural AI risk across the whole enterprise.
So, to actually figure this out, we are pulling a genuinely brilliant framework straight from Chapter 15 of the AI Governance and Responsible AI 500-chapter extended training course. If you don't know it, it's this massive enterprise-grade guide that covers the whole shebang, from MLOps and LLM governance all the way to audits and capstones. It's basically the ultimate playbook designed to drag organizations out of total chaos and get them up to regulator-grade compliance.
Here's a quick look at our roadmap for today. We're going to hit the AI visibility problem, a really great team driver analogy, the 5 maturity levels, the 4 assessment dimensions, some real-world governance examples, and finally, how to avoid the dreaded paper tiger.
All right, let's jump right into Section 1, the AI visibility problem. It turns out flying blind without a centralized AI inventory is the root cause of almost every major AI disaster. The mantra you need to remember here is stop guessing, start measuring. Because without an objective maturity model, individual software squads just start secretly deploying machine learning models on their own. It's a phenomenon called shadow AI. And unmonitored shadow AI leaves companies wide open to some truly devastating legal and financial liabilities. We're talking multi-million-dollar fines under things like the EU AI Act, or worse, algorithmic disgorgement. That's a fun one, where regulators literally force you to destroy your algorithms and all the data they were trained on. Yikes!
Moving on to Section 2, the team driver analogy.
To make this whole abstract governance framework super clear, we found an analogy that just completely hits the nail on the head. Scaling enterprise AI is exactly like a teenager learning how to drive. Think about it. You start at level 1, which is basically chaotic arcade video games, where a kid is just crashing into walls with zero real-world consequences. Then comes level 2, the learner's permit stage, where they have a paper rulebook, but, they still panic. Level 3 is the defensive driving graduate who rigidly follows a strict checklist. Level 4 is your professional fleet vehicle logging real-time telemetry. And then finally level 5. This is the elite, autonomous safety architecture, where anti-lock brakes and collision avoidance systems trigger at machine speed before a human can even blink.
Okay, Section 3, the 5 maturity levels. So let's map that driving analogy directly onto corporate AI infrastructure and see how it builds. At level 1, it's the Wild West. Everything is totally reactive and unmonitored. Developers are just treating models like traditional code with absolutely zero bias checks. By level 2, companies start waking up to the risks, but they're relying on manual paper checklists right before a launch, and let's be real, those are super easy to skip when you're rushing to meet a deadline. Now level 3 is where things actually get structured. You get a mandatory central registry that tracks every single asset and requires formal, cross-functional sign-offs. Level 4 takes it up a notch by introducing live mathematical telemetry, so continuous streaming of quantitative performance data. And finally, level 5 is the holy grail, self-healing. Governance becomes a native part of the tech stack that automatically neutralizes threats. Imagine locking out a model that's experiencing severe drift in a matter of milliseconds. That's level 5.
Section 4. The 4 assessment dimensions.
One huge takeaway here is that you simply cannot just look at the software to grade a company's safety posture. A true risk auditor is going to evaluate 4 very distinct pillars. First up is people. Are your staff actually trained to run active overrides? Second is process. Is there an unbroken audit trail tracking a model from its initial design all the way to retirement? Third, technology. Are there active semantic guardrails in place, or are these things just unmonitored black boxes? And fourth, data. Has the data provenance been thoroughly vetted to prevent personal data leaks? You absolutely need all four of these dimensions locked in tightly to achieve real structural safety.
All right, let's look at Section 5, Real-World AI Governance.
I want you to notice the stark contrast between these two real-world scenarios. Over on the one side, you have a Level 1 global retail bank. They suffered massive fair lending violations, all because a marketing squad quietly deployed a pricing algorithm that developed silent concept drift, which ended up overcharging historically low-income neighborhoods. It was a mess. But then look at Capital One's Level 4, gold standard. They literally wrap every single underwriting algorithm in an automated continuous monitoring pipeline. That pipeline calculates fairness metrics across demographic subgroups every 24 hours. The difference between Level 1 and Level 4, it's literally the difference between an existential company crisis and seamless business continuity.
Now, what is really fascinating to me about this is that it proves true maturity is measured in code, not just in glossy policy documents. Take a look at this Python script. This is an actual automated system gate. It evaluates an AI model's deployment package, reads its internal maturity score key, and basically acts as a programmatic bouncer at the door.
And right here is where we see those results in action. The deployment pipeline instantly freezes a production container. Why? Because the development squad tried to launch a high-risk model using an unapproved manual workflow. The system just rejects it programmatically. No way! Not happening. For a massive enterprise, this exact mechanism is what stops dangerous models from ever reaching your consumers.
Finally, Section 6, Avoiding the Paper Tiger. Upgrading your maturity level is absolutely crucial, but you have to navigate around some incredibly common enterprise traps. The biggest one? The paper tiger mirage. Look, having an exceptional corporate ethics PDF on your company intranet means absolutely nothing if your data science teams have zero software testing tools or automated gates. It's just paper. The other big one is the boil the ocean trap. You can't just take a chaotic Level 1 organization and push them straight to Level 5 overnight. If you apply that kind of sudden, immense bureaucratic pressure, you'll just freeze engineering velocity completely. And you know what happens then? You'll drive your frustrated developers right back into the shadows to build more unmonitored shadow AI. It has to be a step-by-step graduation.
So as you look at your own organization's AI deployments, and considering the absolute breakneck pace of innovation happening right now, you really have to ask yourself a hard question. Are your systems actually backed by continuous, self-healing telemetry that's truly ready for international regulators? Or, when you pull back the curtain, are you still just playing a Level 1 arcade game waiting for the inevitable crash? Start measuring your maturity today, because honestly, the cost of guessing has simply become way too high. Thanks so much for joining me on this explainer, and I'll catch you next time.
Okay, let's just jump right in. Today, we are building the physical organizational engine that actually drives enterprise AI safety. We're talking about the AI Governance Office, or AIGO. For this explainer, we are pulling some absolutely incredible insights straight from Chapter 16 of the AI Governance and Responsible AI 500 Chapter Extended Training course. If you haven't checked it out, it's literally an enterprise-grade masterclass covering everything from frameworks and regulations to MLOps, audits, and real-world corporate cohorts. But our focus right now is really simple. How do we stop treating AI safety as some manual afterthought checklist and actually start building a highly structured, code-enforced command center?
So, here's our roadmap for this explainer. We're going to take you from the core concepts of building that dedicated command center, all the way through to passing automated deployment gates, and of course, how to dodge some major pitfalls along the way.
All right, let's kick things off with Section 1, the Dedicated Command Center. We've got to start by busting a pretty massive myth about how you actually handle AI risk. You know, when companies first try to implement governance, executives almost always just turn to their existing departments and say, hey, you handle AI compliance now. But handing AI off to your standard legal desk or your traditional IT team, it's pretty much a guaranteed path to failure. Why? Well, think about it. Your corporate legal team definitely understands statutory text, but they can't exactly audit a complex Python pipeline, right? And standard IT tends to treat AI like traditional, deterministic software. They completely miss the silent, probabilistic failures that are entirely unique to machine learning. Things like subtle data drift, where a model's accuracy just slowly degrades over time as real-world data changes. So without a centralized hub that's specifically built for these mathematical nuances, massive liabilities are just going to slip quietly right through the cracks.
Think of it kind of like hospital infection control. A massive hospital network doesn't just hand their nurses a pamphlet on hand washing and, blindly hope for the best. Just like an infection office actively runs daily bacterial swabs and will literally shut down a contaminated wing, the AIGO monitors live software. They standardize the pipeline checklists, they actively hunt for mathematical contamination, and most importantly, this is absolutely crucial, they have the ultimate authority to trigger the kill switch on a malfunctioning model to protect the institution. It is entirely active, not passive.
Moving right along to Section 2, choosing your AIGO blueprint. Now, how you actually architect this command center is going to depend entirely on your company's scale. The first option we have is the centralized command model. In this setup, you've got a single, powerful core department that employs all your risk analysts and governance engineers. Every single AI project globally has to be routed through this one central bottleneck for intake and cryptographic sign-off. And look, it creates absolute consistency, which is fantastic for compliance. But if this office is understaffed, it can quickly turn into a massive bureaucratic nightmare that just completely throttles your engineering speed. So to avoid that bottleneck, larger enterprises usually rely on the federated hub-and-spoke model. You establish a lean core hub to set the master policy boundaries. But here is the real secret sauce. You embed specialized spoke governance leads directly into your active business units, like your banking or HR teams. By placing these governance leads physically on the engineering floors, you keep your time to market hyper-fast. Because these embedded leads actually understand the unique context, the constraints, and the weird data quirks of their specific product squads, ultimately, it's a classic trade-off. The centralized model gives you incredibly tight control and makes audits super easy, but you really risk slowing everything down. On the flip side, the federated model keeps your sprint velocity high, but it introduces a pretty major risk. Those regional units might start quietly relaxing the rules, just so they can hit their own financial volume targets. So if you do go federated, you have to make sure those embedded leads report directly back to the central hub, not to their local managers. You have to protect them from that commercial pressure.
All right, Section 3, the AI Governance Squad. So, who actually lives inside this containment squadron? Who are you hiring? First up is the Chief AI Governance Officer, or CAIGO. This is an executive-level leader who bridges the massive communication gap between your highly technical data scientists and your board-level executives. The CAIGO commands the entire office, they sit on the Corporate Risk Committee, and they essentially act as the ultimate shield for the institution's global algorithmic risk posture. Next, you need an AI privacy and sourcing architect. Working right alongside your data privacy officer, this architect's job is to audit exactly where your training data came from. They are out there hunting down restrictive open-source copyleft licenses, and if you don't know, those are viral software licenses that could accidentally force your company to make all your proprietary secret code totally public just because you used an open-source dataset. They also verify consent layers and make absolutely sure all data passes strict PII, personal identifiable information scrubbing proxies, before a model ever even gets trained.
Then we have the MLO Ops Governance Engineer. This is the technical muscle of the operation. They are deeply hands-on. They aren't just reading through policy documents. They are literally physically configuring the cluster networks to block any unsigned model deployments. They build automated fairness, bias, and security checks directly into your CI/CD pipeline. That's your continuous integration and continuous delivery pipeline. Basically, the automated code track that actually pushes your software live to your customers.
Finally, we've got the Algorithmic Assurance Auditor.
Think of them as your procedural risk analyst. They are hyper-focused on record-keeping, validation metrics, and live production telemetry. Because when external watchdogs or international regulators come knocking, and they will, often threatening multi-million-dollar fines, this auditor is the one who packages up all the forensic evidence. They gather the model cards, the drift logs, the whole shebang to definitively prove that your enterprise is operating totally within the law.
Let's dive into Section 4, the 90-day launch roadmap.
Okay, so you have the blueprint, you've hired the team. How do you actually turn the lights on without completely paralyzing your company's daily operations? You need a progressive 90-day map. In month 1, you lay the foundation. You publish your master charter and force every single unit to register their active AI apps into one central inventory. Then, month 2 is all about embedding quality gates. You inject programmatic locks directly into your code repositories, which automatically flags any developers who try to push high-risk models without getting clearance first. And then month 3, that's the fun part. You activate your live observability dashboards and you start running surprise kill switch drills. It's literally like a corporate fire drill, but for AI. You have to verify that if a model starts drifting or malfunctioning in the wild, your team can isolate it and shut it down in under 10 minutes flat.
Next up, Section 5, Passing the Gate Review.
Let's look at a real-world scenario with a fictional company, FinTange Global, to see exactly how these gates stop a non-compliant AI right in its tracks. Let's say FinTange tries to launch an AI called RecruitMax to scan 500,000 resumes a month. But the AIGO steps in and intercepts the launch. Step 1, they mandate data anonymization because they find out the training data contained unredacted personal info. Huge red flag. Step 2, they force the engineering team to retune the entire model to pass the legal 4/5 fairness rule. That's a standard compliance threshold to make sure the algorithm isn't inadvertently screening out specific demographics. And step 3, they enforce a human in-the-loop override. This ensures that if the AI spits out a low confidence score on a candidate, it goes to a real human recruiter instead of just triggering some automated rejection email.
And what's really brilliant about this setup is that it's grounded in actual code. When you build an automated validation gate, you use a Python script, or something similar, to prove the gate isn't just an administrative paper form that people can ignore. It is an automated code barrier. The infrastructure literally crashes the software build and drops the code execution attempt if the mathematical safety bounds aren't met or if the digital signature keys are missing. It completely removes human choice from the equation. That temptation for a developer to say, let's just ship it anyway, gone, completely eliminated.
Finally, let's wrap up with Section 6, Avoiding Governance Pitfalls.
Look, to prevent your brand new AIGO department from just collapsing into useless, annoying bureaucracy, you absolutely must avoid 3 massive failure patterns. First, do not create a paper tiger. That's what happens when you publish these massive, super strict policies, but you provide zero technical infrastructure or actual kill switches to enforce them. Second, avoid the ivory tower trap. If you staff your governance office purely with non-technical lawyers making people fill out slow manual compliance forms, your engineers are going to get incredibly frustrated. They'll just start building unmonitored shadow AI in secret just to avoid the hassle. And third, watch out for the one-and-done system. That's when you audit a model on launch day, slap a sticker on it, but completely ignore live runtime telemetry, which means you will entirely miss post-launch data drift when the real-world environment inevitably changes. So I'll leave you with this thought. True AI governance isn't about writing pamphlets or holding meetings. It's about building a real operational command center with infrastructure-level locks. Take a really hard look at your own organization right now. Is your AI governance just a paper tiger, or are your deployments genuinely secured by code? It's time to start mapping that inventory, embedding those technical gates, and actually empowering your squad today. Thanks so much for joining me on this explainer, and I'll see you next time.
Okay, let me ask you something. Will your AI startup actually survive a $5 million venture capital audit? I mean, seriously, think about it. Picture this. Your fast-moving, agile team has built an absolutely incredible AI application.
User growth is totally exploding, you're hitting all your metrics, and you're finally sitting across the table from institutional investors who are ready to hand you a massive check. But then, they open up the hood of your tech stack. They start digging for compliance, safety, and data sourcing logs. Would your current AI setup withstand that kind of intense scrutiny? Or would the whole deal just instantly fall apart?
Well, let's dive right into this. Welcome to today's Explainer, where we're going to unpack exactly how AI governance scales perfectly to fit literally any organization. We are pulling this directly from Chapter 17 of the AI Governance and Responsible AI 500-chapter extended training course. If you don't know it, it's this incredibly comprehensive enterprise-grade curriculum covering governance frameworks, regulations, risk, LLM governance, MLAOps, audits, case studies, you name it. It's designed for both self-paced learners and corporate cohorts. But today we're focusing entirely on the huge divide between tiny startups and massive corporate enterprises, and how safety looks wildly different for both.
So here's our roadmap for this explainer. We'll start with a Goldilocks dilemma, move to our core analogy of speedboats versus cruise ships, track the startup maturity evolution, look at some real-world case studies, run through a VC pitch audit, and finally, we'll demystify governance as code. Let's jump in.
All right, kicking things off with Section 1, the Goldilocks dilemma. So what exactly is the Goldilocks dilemma when it comes to AI governance? You know, when most people hear the word governance, they immediately picture this sterile corporate skyscraper filled with lawyers, endless 50-page compliance forms, and those agonizingly slow board meetings where absolutely nothing gets decided. And hey, for a massive bank, that heavy structure is kind of required. But if you try to force that exact same bureaucratic nightmare onto a 2-developer startup running on a tiny seed budget, you will literally kill the company. They'll run out of cash before shipping a single feature. But on the flip side, if you completely ignore safety under the banner of moving fast and breaking things, well, you build fatal regulatory debt. The trick is to build a framework that is just right for your current evolutionary stage.
Moving right along to Section 2, Speedboats versus Cruise Ships.
Imagine two completely different vessels navigating this dangerous ocean corridor that's packed with shifting icebergs. And those icebergs? They represent AI risks and new regulations. On the left, we've got the Enterprise cruise ship. It's 100,000 tons, carries 5,000 passengers, and if the captain needs to avoid an iceberg, it literally takes a 3-mile runway and rigid checklists across a massive crew just to pivot. Now, on the right, you've got the startup speedboat. It's a nimble, 3-person crew. It can turn on a dime with a flick of the wrist. But here is the catch, and it's a big one. If that speedboat pilot closes their eyes and hits a rock at 60 knots, the boat disintegrates instantly. Both vessels desperately need a navigation map to survive, right? But that map looks very, very different for each of them.
The operational reality matrix basically dictates your entire blueprint. Look at the risk profile for a second. For an early-stage startup, the risk is existential. Just one lawsuit or a failed audit means immediate bankruptcy. Game over. But for a mature enterprise, the risk is systemic. Think class action lawsuits or massive global turnover fines. Because of this, an enterprise requires a multi-million-dollar, fully institutionalized department. A startup, though, with basically zero budget, they need a super lean, embedded approach, where safety is just a shared cultural habit built directly into their day-to-day code sprints.
Which brings us to Section 3, the Startup Maturity Evolution. Governance is basically a staircase. At Step 1, the MVP stage, you really don't need fancy, expensive software. The founders just need to enforce what we call a culture of tracking. Every single time they download a dataset, they just log the origin and the license in a simple open-source markdown file right in their code repository. Then, at Step 2, Series A, the startup hires more engineers, right? So they add an automated proxy layer. This uses basic inline scrubbers to strip out personally identifiable information, or PII. Finally, Step 3, Enterprise Growth. When they start selling to Fortune 500 banks, that's when they implement a full clearance gate.
They appoint dedicated risk architects and go through formal external audits like ISO 42001.
Okay, Section 4, Real-World Case Studies.
Now, before we look at a major failure, we really have to talk about this incredibly dangerous illusion. We're too small for rules. So many founders mistakenly believe that just because they only have 5 employees, massive global laws like the EU AI Act will just somehow ignore them. But regulators do not care about your corporate headcount. They enforce safety standards based on the real-world human impact of your algorithmic errors.
So let's see what happens when you actually fall for that illusion. Consider this European startup called BuyMiles. They built an AI-driven car insurance app, and honestly, they were growing incredibly fast. But to train their model, they set up these automated web scraping scripts and pulled millions of GPS driving profiles straight off the internet, totally ignoring data provenance. Well, when they pitched for a $5 million Series A, the VC firm did what VCs do. They ran an audit. And those auditors discovered the dataset was actually protected by a highly restrictive copyleft license, and it contained unredacted European citizen tracking profiles without any GDPR consent. The result? The VC firm instantly pulled the $5 million. Gone. And because that contaminated data was baked directly into the model weights, BuyMiles was forced to completely delete their entire AI model. Lacking the cash to rebuild from scratch, they liquidated and went totally bankrupt in just 3 months. The takeaway here, public web data can be financially radioactive.
Now, let's flip the script and look at the enterprise centralized model. JP Morgan Chase has this Omni AI platform designed for literally thousands of internal analysts. At this colossal scale, they obviously cannot rely on a localized culture of tracking on a markdown file. They have to enforce centralized infrastructure code locks. No engineer can unilaterally push a container to production without passing through a highly automated governance pipeline. They use these dynamic telemetry dashboards that constantly compute risk metrics, streaming them live straight to the chief risk officer. At enterprise scale, automation absolutely must replace human trust.
All right, Section 5, the VC due diligence pitch audit.
Okay, put yourself in the hot seat for a second. Imagine you are the CTO of Health AI Labs. You're a 6-person startup pitching for a $2 million seed check. The venture capital auditor leans across the boardroom table, stares you right in the eye, and asks, "Walk me through your data provenance pipeline and input safety controls. How do you ensure our venture capital isn't exposed to severe data privacy liabilities? How do you even respond to that without totally paralyzing your agile little team?"
Well, this is exactly where the lean response playbook saves the day, and more importantly, secures the investment. First, the CTO just opens up their software repository and presents an unalterable sourcing manifest. This proves that 100% of their files carry clean, open commercial use permissions, stuff like MIT licenses. Next, they verify their inline PII anonymizer proxy, proving that patient data is automatically stripped out right at the network border. And finally, they display their open source guardrail configuration, proving the model literally cannot execute malicious jailbreaks. The VC firm sees this lightweight, super affordable compliance culture that doesn't slow down execution at all. Boom, the startup wins the $2 million check.
And finally, Section 6, governance as code.
Now, don't let the Python code here intimidate you. What this brilliantly illustrates is just how incredibly simple governance can actually be. We're looking at a lightweight, zero-cost PII scrubbing filter written in Python. Before any user prompt is ever sent to an external API, this automated script just intercepts it. It uses simple, regular expressions, rejects arrays, to hunt down sensitive data, like social security numbers or emails, and it just overwrites them with safe tags, like redacted email. It takes less than 3 seconds to execute during a code check-in. It costs absolutely nothing in software procurement, requires 0 manual paperwork, and builds a massive, massive wall of defense.
If there's one overarching lesson we've learned from this explainer, it's this: automation must replace trust. Whether you are a nimble 5-person team working in a garage to protect your seed money,
or you're a massive global bank managing billions, governance is ultimately about programmatic systems. You have to embed safety directly into your code sprints so that it just becomes an invisible, totally frictionless part of your daily execution.
So, we've successfully mapped the ocean for both the startup speedboat and the massive enterprise cruise ship. But I want to leave you with a bit of a provocative thought here. You now know exactly how to build a lean, embedded governance culture for a single product line, right? But what happens when your business absolutely explodes and you suddenly have to scale these same rules across hundreds of separate global product lines? How do you handle massive compute cloud cost spikes and deep, stubborn organizational resistance? How do you maintain control then? Well, that massive scaling challenge is exactly what gets unpacked next in Chapter 18 of the training course. Until next time, keep innovating and keep it safe.
Let's jump right into this explainer. Today we're tackling a massive problem in the industry right now, and that's the core challenge of scaling responsible AI. I mean, going from a neat little lab sandbox to a full-blown enterprise level. We're actually pulling some absolutely fascinating insights from Chapter 18 of the AI Governance and Responsible AI 500 Chapter Extended Training Course. It's this incredibly comprehensive enterprise-grade program that covers everything from regulations and MLOps to LLM governance. But this specific chapter, it zeroes in on a really critical transition point. Like, what actually happens when you take an AI safety framework that works beautifully for one single model and you try to force it across an entire global infrastructure? Well, as we're about to see, you slam right into what's known as the scaling wall.
So we start with what the course calls the small sandbox illusion. Picture this. An enterprise builds a single, highly funded AI project. Let's say it's a credit card fraud detection model, right? They spend 6 months on it. They manually write these intricate custom bias checks, build airtight guardrails, and honestly, it performs perfectly. The executive board is thrilled. But then they issue this incredibly dangerous, scale-demanding directive. They say, this was incredible, now we want all 400 product groups across our global banking, human resources, marketing, and wealth management divisions to implement this exact same responsible AI framework by the end of the quarter.
And bam! That right there, that is the exact moment the entire system just completely shatters. I really want you to pay attention to this, because multiplying a manual, paper-heavy safety workflow by hundreds of engineering teams hits a massive operational wall. Actually, scratch that. It's not just a wall, it's complete paralysis. What worked perfectly in a heavily funded, isolated laboratory turns into a massive bottleneck that completely tanks your engineering speed, absolutely spikes your cloud computing costs, and frustrates your entire developer workforce. Scaling AI safety, it isn't about writing better policy brochures, you know? It's a massive engineering optimization challenge.
There's this really brilliant analogy used in the source material that perfectly illustrates the problem. Think of a manual design garage where these elite mechanics are hand-building a single, flawless sports car over 6 months. They are manually measuring every single bolt with a micrometer. It's literally an artisanal masterpiece of safety. Now imagine attempting mass production with that exact same method. If you force factory workers to stop a massive conveyor belt every 10 seconds so a committee can manually measure a screw with a ruler and fill out a paper binder, your production rate is going to drop to 0 instantly. You simply cannot apply handcrafted safety checks to a modern automated factory. If you do, frustrated workers are just going to start quietly bypassing the checkpoints just so they can hit their quotas.
This massive disconnect creates 3 very precise scaling bottlenecks the second a corporation attempts to operationalize AI governance. First, on the technical side, models start feeding into each other. It's a mess. Second, financially speaking, running continuous brute force safety math on millions of automated transactions causes your cloud costs and, honestly, your carbon emissions to absolutely explode. And third, culturally, well, if you slow developers down with endless paperwork, they will actively rebel against the governance office.
Let's zoom in on that technical hurdle because it is so severe. In a true enterprise architecture, models do not live in isolated little bubbles.
we get what's called emergent systemic behavior. Basically, the output of Model A becomes the direct automated input for Model B, which then triggers Model C. It creates these crazy unmapped spaghetti lines of dependencies across the network. So if Model A experiences just a tiny 2% drift because of some random change in real-world data, that error gets passed directly to Model B, it gets amplified, and by the time it hits Model C, the system is automatically executing heavily flawed decisions at massive scale.
To really see how catastrophic this can be, let's look at the Unified Medical Insurance Network disaster. It is a textbook example of a multi-model cascade. Get this, a regional hospital simply updated their database formatting. All they did was change a smoker history column from a numerical 1 or 0 to the text strings true or false. That's it, just a tiny format tweak. But Model A, which was a clinical model, was explicitly expecting a number, so it failed silently. It misread the text string as a 0, which the system interpreted as absolute perfect health for every single applicant. Then Model A feeds these artificial perfect health scores directly into an underwriting model, Model B, which was fully authorized to automatically approve hospital procedures up to $10,000.
And the result? Because of this totally invisible data drift cascade, Model B went completely wild at machine speed. The consortium lost $45 million in unrecoverable insurance leakages. $45 million in a single month. And you know what the absolute scariest part is? Throughout this entire disaster, the individual system dashboards were reporting 100% stability and uptime to the executive board because individually, the models were working, they were just processing completely corrupted assumptions. There was zero end-to-end visibility between the models. Wild, right?
And look, this operational friction feeds right into the cultural bottleneck. If your AI governance framework forces engineers to halt their development sprints, fill out endless spreadsheets, and wait literally weeks for some cross-functional compliance committee meeting, governance suddenly becomes the enemy. Developers are evaluated on execution velocity. If you block them, they are going to seek the path of least resistance for sure. They'll start building unmonitored shadow AI on their personal laptops, or they'll literally use their own personal credit cards to ping external generative AI APIs just to hit their deadlines. You cannot scale safety through cultural policing. It just doesn't work.
So how do mature enterprises actually survive this? They make a fundamental shift from manual compliance to what's called governance as code. They adopt a scaled controls paradigm. Instead of relying on human review boards for every little thing, you take your responsible AI pillars and you embed them directly into the software conveyor belt as automated programmatic sensors. Take fairness, for example. You embed automated metric helper libraries right into the deployment gate. Or for transparency, you use intelligent sampling, meaning you only generate those heavy, expensive math explanations when a model actually rejects something, which saves a massive amount of compute costs.
Under the hood, governance as code looks exactly like this. It's an actual script for a scaled pipeline drift interceptor gate. This little piece of code sits right in between those unmapped spaghetti lines we talked about earlier. It's constantly actively calculating statistical variances, like the population stability index, between different nodes. And here's the kicker. If it detects that a cascading error threshold is breached, it doesn't wait to email a human for permission. No way. It hits a critical failure block, programmatically drops the pipeline runner, and instantly diverts traffic to safe fallback engines. It's essentially an automated circuit breaker.
Let's see how this kind of automated defense holds up in a real-world crisis. Imagine a massive company, global retail commerce. They're running 500 automated customer service chatbots. Suddenly, out of nowhere, a viral social media trend hits. Millions of teenagers start spamming this playful, totally untrained slang phrase into the chat windows. "This product is absolute garbage, give me a refund choice, fam." The bots were trained on textbook English, obviously, so this sudden wave causes massive data drift, and the internal confidence scores just plummet across 12 different countries simultaneously, at 8 in the morning on a Friday.
Now, if they were using manual checklists and review boards, the business would be in absolute chaos for days. But because they have automated telemetry, the response is instantaneous. By 8:05 a.m., the platform calculates that the Population Stability Index has rocketed past the safe corporate boundary and immediately logs a high-severity alert. The system's orchestration control node then executes a pre-authorized defensive maneuver automatically. It swaps all live traffic away from those drifting generative AI models and redirects it straight to a conservative, rule-based challenger model backup. Boom. The entire global business is protected from the slang wave within 5 minutes, and not a single human analyst had to wake up and intervene.
Which leaves us with the ultimate question as you look at scaling your own enterprise systems. Are you still acting like that artisanal design garage? Are you relying on paper binders, manual compliance committees, and just kind of hoping your developers don't bypass you? Or have you made the leap to a modern assembly line, where your safety measures, your drift interceptors, and your fallback triggers are actually hard-coded directly into the infrastructure itself? Because I promise you, in the era of multi-model enterprise AI, paper checklists won't just slow you down, they will completely break your business. All right, that gives you plenty to think about. Thanks for hanging out for this explainer, and we will see you next time.
Welcome to this explainer. Okay, let's just jump right in because today we are tackling what is arguably the single most high-stakes puzzle in enterprise tech right now: scaling your artificial intelligence across global borders without triggering absolutely massive regulatory penalties. We're actually drawing some incredibly valuable insights today from Chapter 19 of a comprehensive AI governance and responsible AI training program. So let's decode exactly how elite enterprises are managing this. So think about the core dilemma facing any multinational corporation right now. How do you actually deploy a single unified AI system when international laws, privacy mandates, and data rights completely contradict each other the second you cross a border? I mean, if you just lazily copy and paste your algorithms across the ocean, you aren't scaling. You are steering straight into a legal minefield. Because the global map is totally fragmented. Just look at how stark these competing philosophies actually are. Over in the European Union, the approach is super rights-driven. An individual's fundamental right to privacy actively overrides corporate data utility, and they back that up with rigid risk categories and massive enforcement. We're talking fines of up to 7% of your global turnover under the EU AI Act. That is huge. Meanwhile, the US operates on a much more market-driven, sector-specific philosophy that's focused on consumer protection. And then you look at Asia and places like Singapore, where it's a very innovation-friendly environment, prioritizing voluntary guidelines to really build up collaborative ecosystems. You simply cannot afford to build 3 completely different AI engines for 3 different regions. The engineering complexity alone would skyrocket. To successfully navigate these incredibly diverse waters, it helps to think of an enterprise AI platform kind of like a global shipping vessel. A massive maritime cargo ship survives by automatically carrying the highest possible standard everywhere it goes, right? Like if the EU mandates ultra-low sulfur clean fuel, but the US requires specialized digital X-ray customs scans and Asia demands automated harbor tracking, the ship doesn't swap out its engine at every single port. It just spurs the clean fuel across its entire journey. Your AI has to do the exact same thing. It needs to run on a design baseline that natively complies with the world's absolute strictest regulations, right out of the box. Here is our game plan for solving this puzzle today. 1. The global AI legal maze. 2. Cross-border data flow traps. 3. The global baseline strategy. 4. Billion-dollar governance failures. 5. Passing the compliance audit. And 6. Mastering enterprise AI governance. All right, starting with Section 1, the global AI legal maze, navigating competing jurisdictions. If your company is just cruising along assuming the cloud is totally borderless, you are inadvertently building a massive, ticking liability. The absolute most dangerous hazard here is the GDPR, the General Data Protection Regulation. Specifically, its restrictions on cross-border data flows. See, deep learning models need continuous, fresh streams of data to prevent performance drift. But under the GDPR extraterritorial trap, moving consumer data across borders is heavily restricted. If your enterprise automatically streams unredacted transaction logs from, say, a branch in Paris straight to a centralized training cluster in Texas, you instantly trigger a cross-border violation. You are literally exporting European privacy rights into a zone that does not share them. Moving to Section 2, Cross-Border Data Flow Traps, Data Residency versus Data Sovereignty. To really grasp this, we need to dive into the technical architecture of data control and unpack the crucial difference between two terms that get mixed up all the time. First, data residency. This is strictly about physical hardware location. It mandates that citizen data absolutely must be stored and processed on hardware servers located inside that specific country's geographical borders. Then, you have data sovereignty, which is all about legal jurisdiction. Sovereignty dictates that the information remains completely subject to the origin nation's privacy laws, even if your cloud provider's headquarters is sitting on the other side of the world. Together, these two concepts totally shatter that old naive dream of a single centralized global data warehouse. Which brings us to Section 3, the Global Baseline Strategy, Designing a Unified Corporate Engine. So what's the actual fix? How do we avoid the one-cloud-fits-all trap, or on the flip side, the incredibly messy and expensive trap of building a completely new system region by region? We use the global baseline strategy. Step 1, you simply adopt the world's highest statutory standard, which is typically the EU AI Act paired with GDPR, and make that your universal corporate-wide rule set. Step 2, force 100% of your primary model training pipelines to automatically pass this extreme safety gate right at birth. And Step 3, instead of rewriting your core code for every single country, you just deploy localized runtime configuration switches to adjust those subtle regional variations right at the edge. It's a brilliantly elegant flow. Your root model files remain naturally compliant everywhere. You're operating one pristine master machine learning pipeline that natively integrates fairness checks and immutable logs. Then, when it's time to deploy to a specific region, software-driven environment toggles just take over. Need to match local monetary guidelines in Singapore? Boom, the toggle flips. Need to land inside localized European cloud instances to satisfy data residency? Another toggle flips, completely seamlessly routing the data without ever altering your core mathematical model. Let's look at Section 4, Billion-Dollar Governance Failures, the cost of cross-border transgressions. Because honestly, what happens when massive corporations fail to implement this baseline and just attempt to raw stream data across the ocean anyway? Well, the stakes aren't theoretical. In May 2023, Meta got hit with a staggering 1.2 billion euro cross-border privacy fine. Let that sink in. That is 1.3 billion US dollars in direct out-of-pocket cash penalties simply for the structural transmission of European citizen data to US servers. So why did this happen to a tech giant? Mostly, it was an over-reliance on fragile, legally invalidated legacy transatlantic frameworks like the old Privacy Shield. But practically speaking, there was a complete absence of localized processing layers. They failed to anonymize or scramble those sensitive consumer tokens before the data actually left the EU jurisdiction. And this didn't just result in a historic fine, it triggered a legally binding mandate forcing a massive, multi-million-dollar re-engineering of their entire global data infrastructure. So yeah, cross-border data flows carry absolute existential risks. But in sharp contrast to that, check out Standard Chartered Bank. They operate across 70 countries, and their chief AI governance office flat out rejected building systems country by country. Instead, they used the global baseline strategy to build one master anti-money laundering algorithmic asset. By using those edge configuration switches to toggle regional transaction thresholds and localized cloud routing, they maintained absolute uniform compliance. And get this, they actually reduced their international operational risk overhead by an incredible 60%. That is a massive win. All right, Section 5. Passing the compliance audit, the global vault defense scenario.
Let's put this into practice for a second. Imagine you are the director of AI governance at a fictional multinational bank. Let's call it Global Vault. Suddenly, a surprise joint regulatory inspection team arrives for a cross-border data tracking audit. How does your architecture hold up? Well, defense number one. When the auditors demand proof that European citizen data compiled in Frankfurt isn't being raw streamed over to California, you just open your cloud management console. You programmatically demonstrate your decoupled regional availability zone architecture. You can instantly prove, without a doubt, that all live consumer data inputs are physically locked inside localized, highly isolated European database regions.
The actual technical implementation relies on things like a Python script acting as an automated, region-aware infrastructure checkpoint running right inside your global deployment runner. It actively evaluates localized safety configurations based on the target country code. So for European regions, the code natively mandates hard data residency mocks and spins up active token anonymization proxies. Do you see how this builds a literally bulletproof defense? If a well-meaning engineering team attempts to push an update to an EU server node, but just forgets to toggle the data residency lock, the inline proxy programmatically catches the violation and instantly blocks the deployment. It just prints a critical failure message and stops the push cold. By relying on automated gates rather than human memory, you breeze through the audit with zero violations.
And finally, Section 6, Mastering Enterprise AI Governance, the Durga Analytics 500 chapter course. Look, to actually build these complex, highly automated controls internally, technical leaders need a deeply robust, enterprise-grade toolkit. The exact concepts we've been exploring today are drawn straight from Chapter 19 of the Comprehensive AI Governance and Responsible AI 500 chapter extended training course. Frameworks like this are absolutely crucial because they bridge that massive gap between high-level regulatory text, like the EU AI Act or NIST frameworks, and actual daily pipeline engineering. It covers everything from LLM governance to MLOps and cross-border risk, giving teams the hands-on labs and templates needed to translate compliance mandates into localized cloud deployments at a global scale.
If you take away just one core principle from this entire explainer today, let it be this. Math can cross borders, PII, personally identifiable information, absolutely cannot. Moving raw customer records across sovereign boundaries is exactly what triggers those severe, potentially business-ending penalties. Your global network architecture simply must transform data into anonymous mathematical abstractions before it ever hits the transit wire.
So I want to leave you with this question to really think about. Are your enterprise models built like that global shipping vessel, running a universal baseline standard, fully localized at the edge, and naturally ready to clear any port of entry? Or are your engineering teams currently raw streaming data in the dark and steering your companies straight into a regulatory shutdown? Thank you so much for joining me for this explainer. Stay focused out there and keep building responsibly.
Welcome to this explainer. Today, we're diving straight into a highly technical masterclass pulled directly from Chapter 20 of the Durga Analytics AI Governance and Responsible AI course. You know, just as a quick bit of background, this is a massive 500-chapter enterprise-grade training. It covers the whole shebang: governance frameworks, regulations, risk, LLM governance, MLOps, audits, industry case studies, templates, you name it. And it's designed for both self-paced learners and corporate cohorts. But today, today we are transitioning out of those broad corporate policies, and we're getting our hands dirty. We're diving right into the code and database layers to figure out how to deploy data systems that respect national borders, without completely crippling your centralized AI.
All right, let's just start with a hard, undeniable truth here. The centralized global data lake, it's dead. Literally dead. I mean, for the past 2 decades, multinational corporations spent absolute billions pooling international customer records into these massive central cloud buckets, right? The goal was obvious: train high-dimensional machine learning models. But today, Well, strict data residency laws have turned that exact strategy into a massive, massive corporate liability.
The stakes of moving unredacted personal information across borders are honestly terrifying. Cross a border illegally, and sure, you invite multi-million-dollar fines. But worse, you risk algorithmic disgorgement orders. This is basically the death penalty for AI. It's a strict legal mandate forcing you to completely destroy your AI's trained model weights. Imagine that. Regulators literally forcing you to digitally lobotomize your AI just because the data it learned from took an illegal trip across the border. Absolutely wild.
So, to avoid that exact nightmare, here's our roadmap. We're going to define the geopolitical data paradox, look at decentralized regional feature stores, privacy-preserving border proxies, federated learning, check out some real-world technical execution, and finally, wrap up with common structural mistakes to avoid.
Section 1. The Geopolitical Data Paradox, the Legal Landscape. Let's get right into the regulatory roadblocks that actually created this whole mess in the first place.
We're talking about modern statutes like the EU's GDPR, specifically those Schrems II judicial rulings, China's Personal Information Protection Law, and India's Digital Personal Data Protection Act. They all establish one non-negotiable rule. A nation's citizen data absolutely must be physically stored, hosted, and processed on computer hardware situated strictly within its own geographical boundaries. The days of just assuming your cloud network is some magical borderless entity? Yeah, those are completely over.
So, this brings us to the ultimate paradox. How do we achieve powerful, unified global AI insights if 100% of our raw consumer data is essentially locked behind localized, sovereign borders? It's a real head-scratcher. The core engineering challenge today isn't just about optimizing algorithm accuracy anymore. It's about securely navigating this brand new geopolitical reality.
Moving on to Section 2. Decentralized regional feature stores, keeping data local. To resolve this paradox, enterprise architects need to replace those old borderless assumptions with 3 explicit patterns, starting with decoupled storage.
Instead of streaming raw transaction logs to some central hub, we have to deploy a data isolation matrix. This is where an enterprise operates completely distinct regional availability zones. Think about it like this. German transaction data is strictly processed on local servers in Frankfurt, totally isolated, while American files route to servers in Virginia. The local database just computes abstract mathematical feature arrays. This ensures zero raw personal data ever crosses the Atlantic.
Section 3. Privacy-preserving border proxies, scrubbing the PII. But what happens when macro-level analytics absolutely must coordinate between these international branches?
You obviously can't just send raw text. We have to use inline proxies, like automated Python scripts, to intercept outbound payloads. These scripts run high-speed text parsing transformations, scrubbing out sensitive identifiers, names, emails, tax IDs, the works. If an unmasked personal identifier even attempts to cross that network border, the script just programmatically drops the transmission right then and there. It takes toxic, personally identifiable information, or PII, and transforms it into safe, legal mathematical tokens before it ever transits.
Now, pay attention here, because there is an absolutely critical legal difference between masking routines. Pseudonymization just replaces a name with a reversible cryptographic token hash. But because it can theoretically be reversed using a key, it is still classified as personal data. That means it's still a massive liability. True anonymization, on the other hand, is totally irreversible. It injects differential privacy, basically mathematical noise, scrambling the data so the human identity can literally never be reconstructed. It completely loses its classification as personal data. It becomes effectively legal math that is perfectly safe to stream anywhere.
All right, Section 4, Federated Learning, Zero Data Transit Frameworks. This is really the ultimate realization of cross-border AI governance.
Federated learning is brilliant because it completely reverses the old centralized paradigm. Instead of bringing the data to the model code, it brings the model code directly to the data, entirely eliminating raw data transit. Step 1. The central hub distributes an empty neural network blueprint down to local servers. Step 2. Those regional nodes execute localized training loops using only their sovereign data. And finally, Step 3. They transmit only abstract mathematical gradients back to the center hub to synthesize into the global model. It's like a giant puzzle where the pieces assemble themselves safely.
Let's look at Section 5, Real-World Technical Execution, from TikTok to Ping On. Let's actually see how these blueprints hold up in the high-stakes real world.
You probably remember TikTok facing a massive geopolitical collision. They had a multi-billion-dollar scramble to build Project Texas and Project Clover, which was this ring-fenced, isolated infrastructure designed retroactively to satisfy regulators. But contrast that with Ping On Insurance Group. They proactively built a federated grid across dozens of regional subsidiaries. By streaming only mathematical parameters and keeping every single piece of patient data locked locally, they boosted their underwriting accuracy by 32%. And they did it with zero compliance breaches. A real game changer.
Here is another brilliant technical playbook, and honestly, the architecture here is just incredibly cool. In a global health diagnostics scenario, they needed to process patient X-rays across Paris, London, and New York without ever moving raw images. The solution? A split inference topology. Basically, Paris edge servers run the lightweight front end, calculating abstract mathematical vector shapes. They transmit only those unreadable layer 4 math vectors across the ocean. Then, the New York core servers crunch the heavy lifting to generate the diagnostic flag. The result? 0 raw patient X-rays ever cross the ocean. Seriously smart stuff.
Which brings us to Section 6, Common Structural Mistakes, What to Avoid. Before we wrap up, we absolutely have to address the fatal patterns that routinely sink multinational data engineering teams. Okay, 3 fatal failure patterns to watch out for. First, the encrypted transit fallacy. You must remember that simply encrypting a VPN tunnel does not legally excuse you from moving unredacted PII across sovereign borders. Second, shared database identity overlap. Allowing shared database connection strings across countries leads to immediate, unchecked data replication breaches. And third, the omission of local schema version alignment control. If you fail to build rigid local schema validation, a remote developer's minor formatting change will cascade downstream and literally corrupt your entire global pipeline. Bad news all around.
To prevent those catastrophic multi-model data corruption cascades, you always need to explicitly map your interfaces against rigid schema contracts. You literally have to map your cross-border data risk vectors directly to the EU AI Act, articles, NIST frameworks, and ISO standards to guarantee absolute regulatory alignment across your global enterprise operations.
So, as we wrap this explainer up, I really want you to take a hard look at your own infrastructure and ask yourself a tough question. Is your centralized AI model a multi-million-dollar compliance liability waiting to happen? If you're still moving raw data across borders, the answer is unfortunately probably yes. To truly operationalize these controls, you should seriously consider checking out the full Durga Analytics AI Governance and Responsible AI 500 chapter extended training course. It's packed with the hands-on labs, industry case studies, templates, and enterprise playbooks you need to master your governance strategy. Thanks so much for joining me on this deep dive into the geopolitical data paradox.
Welcome to this explainer on AI Governance ROI. Now, today we're actually jumping straight into Chapter 21 of Durga Analytics AI Governance and Responsible AI Training Program. Just for some quick context, this is a massive 500-chapter enterprise-grade course. It covers the whole shebang: governance frameworks, regulations, risk, LM governance, MLOps, audits, industry case studies, templates, and capstones. Really, it's designed for both self-paced learners and corporate cohorts. But right now, we're going to extract one of its absolute best lessons: how to take the hard business value of AI governance and actually quantify it. So let's tackle a question that comes up constantly in corporate risk circles. Is AI governance really just an economic tax? You know, a lot of business unit leaders kind of treat compliance like a bureaucratic speed bump, just this annoying thing that drains money and time away from active product design. But in the realm of enterprise AI, man, treating it that way is a massive strategic error. Think about it. Traditional software fails loudly, right? It just throws an error code and stops. But AI engines are probabilistic. They can drift silently, pumping out highly confident but absolutely disastrous real-world decisions.
Actually, I love this metaphor. Doing AI without governance is exactly like driving a Formula One race car that doesn't have any brakes. Seriously, with no brakes, you're only going to navigate that track at, maybe 30 miles per hour? And that's mostly out of sheer terror of crashing into a retaining wall. But the second your engineers install state-of-the-art carbon ceramic brakes, well, those brakes don't exist to slow you down. They exist to empower the pilot to safely push that engine to 220 miles per hour. Okay, moving on to Section 1, the mechanics of quantifying the ROI. So, stepping off the racetrack and looking at the corporate balance sheet, let's unpack the actual math here. The most direct way to quantify this is something called the Value Defended Metric, or VDM. It basically calculates the explicit amount of corporate capital, whether we're talking revenue, market equity, or cash reserves, that gets protected by preemptively installing automated checking gates. And the formula is beautifully straightforward. You just take the statistical probability of a severe failure event happening over a given year, and you multiply that by the total material cost impact of that failure. You run that calculation for your ungoverned state, and then simply subtract the new calculation of your governed state. Let's put some real numbers to this to see it in action. Picture a multinational retail bank rolling out a totally ungoverned machine learning loan model. Let's say it has a 35% probability of drifting into a fair lending violation, which, carries a $40 million cost impact. That leaves them with a $14 million risk exposure. Yikes. But if they spend $1.5 million up front on MLOps monitors and fairness gates, they drop that failure probability all the way down to just 2%. So their new risk exposure is only $800,000. By subtracting the governed risk from the ungoverned risk, we can see the bank successfully defended $13.2 million in risk-adjusted capital. That's a 780% net financial return, going straight to protecting the bottom line. Absolutely crucial stuff. Now, another critical financial mechanic we need to talk about is the algorithmic scrap rate. Think about traditional manufacturing. Plant managers are always tracking the scrap rate of, deformed materials falling off the assembly line. Well, in machine learning pipelines, it's the tragic waste of massive cloud computing bills and hundreds of engineering hours when a fully trained model gets vetoed by the legal department right before launch. And usually that happens because someone finally noticed data poisoning or a copyright violation or some severe bias at the literal last second. The huge takeaway here is that by embedding automated data provenance checks right at the ingestion phase, you elevate from a chaotic level 1 maturity to a governed level 4 pipeline. You aren't sitting around waiting until the model is completely built to check the data. By forcing those automated checks right at the start, organizations reduce that 100% legal veto scrap waste down to exactly 0. You maximize your engineering output and save millions in wasted compute capital. It's a total game changer.
All right, let's get into Section 2, the proof, where we'll look at some real-world disasters and successes. First, let's look at how this plays out when it goes horribly wrong. Consider the Project Alpha AI disaster. This was a Tier 1 multi-billion-dollar asset management firm that launched an aggressive trading initiative using deep reinforcement learning. Now, to maximize speed, the engineering leads actively pushed back against corporate risk oversight. They actually called it an innovation inhibitor and completely bypassed the governance gates. But within just 3 weeks, a sudden geopolitical election event triggered a massive shift in tech sentiment. It was a textbook case of nonlinear concept drift. And because this ungoverned model had literally zero real-time input stability gates or independent monitoring telemetry, it entered a dangerous recursive optimization loop. The fallout? Devastating. The model drained $42 million in cash capital in exactly 54 minutes. Just drained it, right up until an engineer physically pulled the server plugs. That triggered a $12 million regulatory fine, and absolutely terrified institutional investors sparked an $8.5 billion capital flight. Like we said earlier, that is the brutal reality of driving without brakes. Conversely, let's look at a major win. A healthcare network was building an advanced AI lung CT diagnostic tool called OncoPredict ML. They were smart. They realized that rushing a black box model into the highly regulated medical space would cause huge friction, so they intentionally paused. They spent 6 months building out a robust Level 4 responsible AI architecture. They incorporated verifiable explainability heat maps so doctors could actually see exactly why a cell was flagged. And they went all the way to secure formal ISO 42001 certification. The commercial payoff for that pause was absolutely staggering. Because of that verifiable transparency, they earned a 45% pricing premium over their cheaper black box competitors. And here is the compliance dividend at work. Since their safety records were standardized and verifiable, enterprise buyers were able to slash their internal procurement cycles from a typical 9 months down to just 14 days. So governance actually accelerated their time to market while completely insulating the firm from malpractice claims. Win-win. Which brings us to Section 3, the climax, aligning the boardroom. So how do you take these mechanics and these wild case studies and actually pitch the required capital expenditure to your C-suite? Well, it takes perfect cross-functional boardroom alignment. You don't walk in and pitch abstract ethical principles to a CFO. Never gonna work. You have to translate safety parameters into hard capital metrics. The CFO wants a positive ROI. The strategy team wants to hit a 90-day launch to grab market share. Enter the Chief AI Governance Officer, who proves that automated code gates satisfy everybody. They protect the treasury through cost avoidance, and that automated compliance actually speeds up the 90-day rollout. For a great practical example, let's look at Global FinCorp. They deployed a large language model wealth assistant. By setting up real-time output filters to block rogue trading advice, financial hallucinations, they dodged an estimated $15 million in regulatory fines. Plus, their automated model card compilation cut their rollout time from 9 months to just 45 days. 6 months after launch, the CFO reviewed the numbers and confirmed their AI governance investment delivered a net financial return of 540%. Incredible. So the big takeaway here is that governance isn't a bottleneck. It is literally your premier value protection engine. I want to leave you with this final thought to chew on as you scale these amazing technologies in your own enterprise. Are you driving your artificial intelligence at 30 miles per hour out of absolute terror? Or are you driving at 220 miles per hour, totally out-innovating your competition because you're equipped with the high-performance brakes of AI governance? Thanks so much for joining me for this explainer, and as always, keep learning.
Welcome to the Explainer. So today, we're diving into something absolutely crucial, and honestly, a bit of a mind-bender. We're unpacking the cultural metamorphosis that actually makes AI governance work in the real world. We're pulling directly from Chapter 22 of the incredibly comprehensive AI Governance and Responsible AI 500-chapter extended training course by Durga Analytics. It's an enterprise-grade masterclass built for corporate cohorts, covering everything from LLM governance to ML ops. But today, we're zooming in on the human element. How do we get technical teams to stop looking at governance as this giant, annoying roadblock and start treating it as just a normal, effortless part of writing code? It's a massive shift, but as you'll see, it is entirely possible.
Okay, to really get why AI governance usually falls flat on its face, we actually need to step outside of the tech world for a second.
Imagine you're the chief medical director at a massive metropolitan hospital, right? And suddenly there's a terrifying spike in postoperative infections. What's your move? Well, the standard corporate reflex is to write up a 200-page manual on sterile techniques, print out a massive 50-step hand-washing checklist, slap it on the wall above every sink, and threaten to fire anyone who skips a step. Sounds completely logical on paper, doesn't it? But let's think about how that actually plays out in a life-or-death emergency.
Picture an elite trauma surgeon rushing into the ER to save a hemorrhaging patient. They hit the sink and boom, they experience this immediate, massive cognitive clash. They look at the bleeding patient, they look at the clock, and then they look at your giant 50-step chart. And their conclusion is instant. If I stand at this sink for 7 minutes completing this compliance paperwork, my patient will literally die on the table. So what do? They bypass the checklist entirely. They scrub in fast, saving the patient in the moment, but unintentionally introducing a fatal systemic infection risk down the line.
You know that hospital scenario? It perfectly mirrors the reality inside enterprise AI development teams. When corporate leadership rolls out a new governance initiative using what we call the paper compliance mirage, uploading a dense legal handbook and a massive risk-tiering checklist to the company intranet, it's a dangerous illusion. Highly skilled data scientists and engineers, they're exactly like those trauma surgeons. They are under immense pressure to deliver, driven by extreme speed incentives. If governance feels like a heavy administrative burden that ruins their sprint velocity, they won't do it. They'll just view it as a blocker and find a way around it.
Let's look at a spectacular real-world failure from the course's Retail Titan case study to see this in action. A massive retail company set up a centralized compliance group staffed mostly by traditional risk attorneys. Their brilliant solution? Before deploying any machine learning model, the engineers had to manually fill out a 60-page Excel questionnaire and wait 4 whole weeks for committee approval. 60 pages! The result was an immediate spectacular catastrophe. Faced with crushing holiday sales deadlines, the developers just went completely underground. They bypassed the central network, spun up models on their own personal laptops, and literally used their personal credit cards to hook up customer service apps to external AI APIs. And, yep, that caused a massive ingestion leak of completely unredacted consumer data.
And the fallout from that cultural failure? It was swift and it was brutal. Within just 4 months, an unmonitored product optimization model running in this hidden network experienced severe target leakage. Basically, it found a mathematical shortcut and started automatically blasting out thousands of highly overinflated promo vouchers to invalid accounts. Because it was running entirely off the grid, nobody noticed for weeks. It ended up draining a staggering $18 million in direct margin losses right off the balance sheet. $18 million! And this brilliantly illustrates the whole structural failure path. It all starts with that ridiculous, rigid 60-page Excel form. That direct friction sparks engineering gridlock, which leads to developer frustration and the inevitable downstream collapse, an unmonitored rogue swarm. Because developers don't just stop building, they just build in the dark. You end up in a nightmare scenario where 80% of your corporate models are running as hidden shadow AI. You see, heavy paperwork doesn't actually eliminate risk at all. It literally just drives it underground.
So how do we fix this? Well, first, we have to decode this developer resistance, and we have to do it with empathy, not blame. Why do they push back? First off, there's optimism bias, or the lab illusion. Data scientists build these beautiful, complex statistical models and naturally assume that if the math works perfectly in a pristine lab environment, it'll work flawlessly in the messy real world. Second, we have a principal-agent misalignment. Business leaders are handing out bonuses for immediate commercial results, like boosting loan conversions. So suddenly, risk and compliance alerts feel like a direct threat to a developer's paycheck. And finally, there's metric manipulation, also known as Goodhart's Law. If you force a team to hit static compliance metrics without actually changing the culture, they'll just artificially optimize for the metric itself, completely masking the real systemic risk. Now, what's really interesting about this slide is the sheer disconnect it exposes across three critical corporate roles. When things go sideways, these people enter a boardroom and they are quite literally speaking different languages. The data scientist is talking about atom optimizers and cross-entropy loss. The risk officer is totally laser-focused on residual risk profiles and Tier 1 capital. Meanwhile, the legal counsel is in the corner quoting compliance definitions from Article 10. It's a mess. To fix this, an organization absolutely has to build a bilingual translation layer. You need a system that translates those abstract legal and regulatory rules directly into concrete, code-enforced engineering assertions that everybody can actually understand and align on.
Fortunately, there is a proven alternative to this chaos. And that brings us to an incredible turnaround story of a premier healthcare and insurance giant in Western Europe. They completely revolutionized their approach by adopting the Durga model. They needed to deploy predictive machine learning models for critical care, but the chief risk officer was smart. He knew that dropping heavy top-down compliance checklists on a bunch of brilliant medical data scientists would cause massive friction. So they did something radical. They totally rejected traditional policing and went all in on a structured, peer-led cultural transformation.
Their first major shift? They totally rethought who actually enforces the rules. Instead of sending external legal compliance officers onto the engineering floors, people who generally don't read or write code, they built a network of embedded, responsible AI champions. They tapped highly respected senior data scientists from within every single product squad and trained them to act as peer-level safety mentors. And here's the kicker: these champions kept their day jobs as active programmers. That meant they maintained their street cred, kept sprint velocity high, and managed safety boundaries locally, right where the work was happening.
Next up, they tackled the actual training format. They completely threw out those mind-numbingly boring compliance lecture slide decks. Good riddance, right? Instead, they launched gamified, algorithmic red teaming tournaments. Once a quarter, development teams were offered a cash bonus to actively try and break, jailbreak, or find hidden vulnerabilities in another team's staging models. It is such a brilliant move. It takes algorithmic safety from being this irritating legal chore and turns it into a highly engaging, prestigious technical challenge. It directly taps into a developer's natural competitive drive.
But honestly, perhaps the most vital piece of this entire cultural puzzle is their adoption of the non-punishable incident review framework. They modeled this directly on the safety cultures you see in aviation and nuclear engineering, where the absolute golden rule is separating blame from cause. If a developer spots a flaw or, hey, even accidentally causes one, they are fully protected. Think about it. If you punish engineers for algorithmic drift or data errors, they'll just stay quiet and quietly write secret, unaudited patches in production. By entirely removing the fear of getting fired, you drive systemic risk completely out of hiding. This framework completely transforms how a massive enterprise responds to a real crisis. Take the Global Retail Corp case study. They deployed a brand new conversational AI support bot LLM. Pretty quickly, it suffered a complex indirect prompt injection attack and automatically issued a $5,000 cash refund to a totally unauthorized account. Yikes. But because they had built a strict, non-punitive culture, the engineer who discovered the exploit wasn't terrified. They openly escalated it immediately. No finger-pointing, no panic. The team just rallied, wrote an inline input validation check, and had the patched version safely back live in production within 4 hours. And the absolute best part? The vice president publicly praised that team at the very next town hall. They literally celebrated the save. So, the crucial point is that you must ground this cultural theory in hard developer reality. It can't just be talk. Look at these Python script snippets. This is governance as code in action. This little script acts as an automated local Git hook. It essentially intercepts the developer's code commit and checks right then and there if they've generated the required model card metadata. If they haven't, it doesn't send them an angry email or a form to fill out.
It just programmatically blocks the commit right at their workbench, giving them a detailed debug log of what to fix. It literally forces compliance to happen natively within the tools they already use all day.
By integrating automated tools like that, you are eliminating manual friction entirely. You're scaling safety directly into the infrastructure layer itself. You can configure the engineering environments to auto-generate those model cards right via the command line interface. You can extract dataset lineage natively from the code in milliseconds. You can even set up your Kubernetes cluster to just automatically block any model container deployment that doesn't have a valid, unexpired cryptographic signature token. Ultimately, you are making absolute total compliance the absolute fastest and easiest path to production.
Which leaves us with this final, incredibly critical question to ponder. Are your corporate compliance rules actively protecting your company, or are they just driving your greatest risks underground? As we've seen today, true AI governance isn't a checklist. It's an embedded, frictionless engineering habit. I really hope this explainer has challenged you to rethink your own organizational frameworks. Thank you so much for joining me, and keep questioning how you build.
All right, let's jump straight into this explainer. Today, we are tackling a massive, honestly existential challenge in the tech world. How do we translate highly technical AI risks into the strategic, financial metrics that actually get a corporate board of directors to sit up and listen? Now, for some quick background, we're pulling our insights today heavily from Chapter 23 of the AI Governance and Responsible AI Extended Training course. It's a massive, enterprise-grade deep dive, covering everything from governance frameworks and regulations to LLM governance, MLOps, audits, industry case studies, the whole shebang. But today, we're zeroing in on the art of executive adoption. So whether you're trying to secure long-term funding or just keep your AI projects from getting the axe, you are in the exact right place. To get us from the developer floor straight up to the boardroom, we've got a really clear roadmap. We'll hit the boardroom communication abyss, the airplane cockpit analogy, decoding C-suite personas, the impact storytelling framework, some real-world case studies, and finally, executive-grade dashboarding. Section 1. The boardroom communication abyss. It is time to cross that translation gap. So, picture this. A brilliant data science lead walks into the boardroom, fires up a 40-slide deck on neural network weight charts, and proudly announces, "Our transformer-based generative agents are exhibiting a 12% semantic divergence." The board, who, let's remember, are experts in corporate finance, not machine learning, they just stare back blankly. They're hitting immediate cognitive overload. To them, semantic divergence sounds like, I don't know, a minor IT glitch, like somebody just needs to restart a router. So their response is predictably swift. Request denied, budget cut, next topic, please. It's a total communication breakdown. Section 2, the airplane cockpit analogy. Let's talk about how to avoid that cognitive overload altogether. Think about a scenario we can all easily relate to. Imagine you're on a transatlantic flight, just cruising along, when suddenly the pilot bursts out of the cockpit. He's holding a laptop showing live binary data, and he nervously yells that the exhaust gas temperature variables have a 0.04 statistical variance. Look, unless you happen to be an aerospace engineer, you have literally no idea what that means. You're just terrified. What that pilot should do is translate that raw log into a flight parameter you actually understand. Like, hey folks, we lost 15% fuel efficiency, so we're diverting to Boston to guarantee a safe landing. Ask yourself, as a passenger facing an emergency, which of those actually helps you grasp the risk? The raw binary logs or the direct flight metrics? Well, the boardroom is your passenger cabin. Your job as an AI risk leader is to take those raw algorithmic binary logs and present them as a clean, clear flight navigation map to the C-suite. Section 3, decoding C-suite personas, because before we build that map, you really have to know your audience. Listen, the C-suite is not a monolith. Every single executive views the enterprise through their own distinct strategic lens. Take the CEO. They're laser-focused on brand equity, market trust, and the stock price. So you need to frame AI governance as a trust premium. The CFO, they're looking at capital and efficiency. So drop the abstract ethical jargon and talk to them about return on invested capital,
cost avoidance, and reducing the algorithmic scrap rate to absolute zero. And the Chief Risk Officer, the CRO, they care about liability. You have to map model drift directly to statutory fines, audit trails, and litigation defense. You absolutely must tailor your pitch to the specific metrics they own.
And that brings us to this fundamental truth of enterprise governance. You simply cannot manage a risk that hasn't been converted into your native professional vocabulary. When an exec cuts your AI safety budget, it's almost never because they're reckless or malicious. It's because you haven't given them contextual translation.
Section 4, the Impact Storytelling Framework. This is essentially the master key to fixing the problem. Corporate risk consultants rely on this specific 4-tier architecture to perfectly sequence the narrative. Step 1 is the signal. That's your raw mathematical anomaly. Step 2 is the business pass, explaining exactly how that math alters a real-world automated choice, like, say, unfairly denying a loan. Step 3 is the material liability, the actual exact financial or legal cost that's going to hit the balance sheet. And finally, step 4 is the strategic remedy, the explicit automated fallback or control required to fix it. That right there is how you turn a confusing technical anomaly into a fully funded strategic solution. Section 5, Real-World Case Studies. Let's look at the actual massive stakes of executive visibility. Just take a second and absorb that number. $440 million. That staggering amount represents the exact cash capital that Knight Capital Group lost in just 45 minutes back in 2012. And why? Because of a single, unmonitored legacy code block on a trading server. The failure path here is honestly terrifying. During a deployment, an engineer accidentally left a dormant script active. But because the technology squads were operating in a total information void, speaking only in programming slang with zero telemetry dashboards for the boardroom, the C-suite was completely blind. So this rogue algorithm just starts executing 40 trades a second at market highs and lows. With no centralized infrastructure kill switch anywhere to be found, the enterprise literally bled to death. It wiped out the bank's net capital and forced a sudden, catastrophic bankruptcy. System visibility belongs in the boardroom. Now, in really sharp contrast to that disaster, let's look at the Goldman Sachs executive defense. They faced an intense regulatory subpoena over alleged algorithmic bias in their Apple Card underwriting system. High-profile consumers were accusing the AI of gender discrimination, and suddenly, regulators are knocking right on the executive suite doors. But Goldman Sachs? They didn't panic. And more importantly, they didn't hide behind confusing math. They leaned entirely on clean documentation and evidence storytelling. They actively avoided complex mathematical formulas and instead handed regulators plain language, untouched data cards. They used these to explicitly prove that the gender variable was never even ingested by the model's training matrices. They delivered pristine, independent audit trails compiled by a separate risk group, demonstrating an absolute separation of duties. By translating technical truth into undeniable executive evidence, they cleared themselves of statutory violations, protected their brand, and dodged some truly massive fines. Section 6, Executive Grade Dashboarding. Let's talk about the actual technical execution of all this. Because, let's be real, you can't rely on manually building PowerPoint slides every single time an algorithm misbehaves. The solution is actually pretty elegant. Simple Python backend scripts acting as telemetry agents. Instead of pinging the board with abstract data drift alerts, these scripts continuously monitor production models and automatically convert those complex technical deviations into quantified financial exposure estimates right in real time. If the total value at risk reaches your corporate ceiling, bam, the system instantly triggers a prioritized dashboard alert. This is what we call putting financial red lines over raw math. You group the enterprise AI portfolio into simple, color-coded risk bands. Green for normal, yellow for minor drift, red for system in solitary sandbox. It gives executives instant, intuitive visibility without the headache.
It means we stop throwing scatter plots at executives and start showing them exactly how many millions of dollars are currently on the line. Got a 15% rise in text hallucinations? The CEO doesn't see a math problem. They see a warning about a potential 25% drop in enrollment and severe brand damage. Someone used unaudited internet datasets. The CFO instantly sees a $3.2 million algorithmic scrap waste alert. Unredacted patient data leak. The CRO gets a flashing warning for a statutory fine of up to 4% of global turnover. You're taking abstract math and making it immediately actionable business intelligence. So I'm going to leave you with this provocative thought today. Evaluate your own reporting structures right now. If a massive AI crisis strikes your enterprise tomorrow morning, are you serving your board confusing raw binary logs, or are you giving them clear navigational flight metrics? The gap between those two things isn't just about communication style. As we saw with Knight Capital, boardroom visibility is the ultimate corporate survival tool. Get your translation layer sorted, and you won't just secure your budget, you'll secure your entire program's future.
Welcome back to The Explainer. If you or your enterprise are building AI right now, well, you already know that just writing up a bunch of policies, that's really just the starting line. Today, we're pulling some absolutely crucial insights straight from Chapter 24 of the massive 500-chapter AI Governance and Responsible AI Enterprise Training course. We're going to completely move past the philosophy and master the actual empirical, quantitative framework you need to measure, and I mean really measure and score, the operational performance of your entire AI ecosystem.
Okay, let's dive right into this. Is your company suffering from AI metric blindness? Seriously, take a second and think about it. Are you relying on false illusions of safety? Look, for things like daily sales or server uptime, your metrics are usually crystal clear. You know exactly where you stand. But when we get into the domain of enterprise AI risk, man, organizations are frequently flying completely blind. They're relying on data that, sure, makes them feel good, but it actually tells them absolutely nothing about their real risk exposure.
And the quote here brilliantly hits the nail on the head regarding the root of the issue. Because responsible AI has historically been treated as this kind of philosophical or purely qualitative exercise, companies typically default to what we call vanity metrics. And these just create a false sense of compliance, security. Having a shiny corporate ethical statement with, 5 core pillars, hey, that's great for PR. But it completely fails to tell your chief risk officer if an active deep learning model is silently drifting into discriminatory exclusions, or if an internal LLM is just leaking private data all over the place. Basically, good ethical intentions do not protect your bottom line. Hard data does.
So here's our roadmap for shifting your enterprise from those soft vanity metrics to hard infrastructural telemetry. We'll cover 1. The metric blindness trap. 2. The nuclear reactor analogy. 3. Leading and lagging indicators. 4. The governance velocity index. 5. Cascading structural OKRs. And 6. Some real-world case studies.
All right, starting off with Section 1, the metric blindness trap.
Just imagine a dashboard bragging that 100% of your data scientists attended a responsible AI seminar. Sounds nice, right? But that is a classic vanity metric. It creates a really dangerous illusion of safety. Because if your system actually collapses into a massive regulatory crash, that seminar attendance sheet, it's not going to save you. Compare that to actual infrastructural telemetry metrics, like tracking algorithmic drift incidents in real time. To achieve true operational governance, you literally have to treat your risk controls and validation pipelines as raw data generators. You're extracting metrics straight from the code itself.
Moving on to Section 2, the nuclear reactor analogy.
So put yourself in this scenario. You're the chief operations officer of a massive nuclear power plant. Your goal is to maximize electricity generation with a 0% probability of a meltdown. 0. Now, you absolutely do not monitor the safety of that reactor by tracking how many pages are in your safety manual or looking at the percentage of employees who signed a code of conduct. That's totally absurd, right? Doing that would result in a swift, catastrophic failure. No, instead, you monitor that reactor by wiring electronic telemetry sensors straight into the physical infrastructure. You're measuring things like core neutron flux density and cooling loop pressure. And here's the kicker. Your enterprise AI portfolio requires that exact same level of control room metric design.
This brings us to Section 3, Leading and Lagging Indicators.
Now, what's really interesting about this workflow is that a mature measurement framework actually needs two distinct pipelines. First up, you have your leading indicators. These are predictive. Think of things like data lineage completeness ratios or out-of-distribution volatility. These metrics are your early warning system. They preempt failure loops by halting a deployment way before a risk actually manifests. And then, on the other side, you have lagging indicators. These are historical. We're talking about things like post-launch drift incidents or algorithmic scrap rate capital loss. Simply put, you need predictive metrics to stop the crash from happening and retrospective metrics to learn from the drive.
Let's jump to Section 4, the Governance Velocity Index.
All right, the Governance Velocity Index, or GVI for short. This is essentially the hero equation of our explainer today. It's a mathematical calculation that balances your time-to-market rollout cycles against your compliance assurance coverage, all while heavily weighting for residual risk. The fundamental message you want to take to your executives is this: governance does not have to be a brake pedal. If it's implemented correctly, it actually measures how efficiently your safety net allows your developers to move fast.
Let's look at three very realistic scenarios here. First, Scenario A, high bureaucracy. This paralyzes innovation with endless manual reviews, leading to a pretty terrible GVI score of 0.40 or less. Then on the flip side, Scenario B, ungoverned velocity. Sure, it's super fast, but it carries massive risk exposure. That drops your GVI below 0.30. But then, look at Scenario C, automated optimization. By using smart pipeline scripting and local Git hooks, your governed speed actually matches your ungoverned speed, and your risk drops to near zero. This peaks your GVI at 0.85 or even higher. It completely proves that automated safety controls act as a high-speed strategic innovation accelerator.
Which leads us into Section 5, Cascading Structural OKRs.
So how do we get to Scenario C? Well, to make these metrics stick, they absolutely cannot live in a silo. They have to cascade through 4 automated phases. Step 1 is the code phase. Here, lightweight workers extract test coverage straight into the registry the moment developers push their code. Step 2 is the staging phase, where build runners just aggregate metadata automatically. Step 3 is production, where open telemetry agents capture real-time traffic without slowing things down. And finally, Step 4 is boardroom synthesis. This is where the central engine aggregates all these variables into actual financial risk statistics. It passes empirical data straight to the C-suite without creating any friction for your engineers.
Let's move to Section 6 and see how this builds into real-world case studies.
First up, let's look at the real-world cost of vanity metrics. We have this global fintech company that deployed consumer underwriting models. Meanwhile, their compliance team was busy tracking, you guessed it, web course attendance. Because they lacked hard telemetry, they were completely blind to a severe issue called target leakage. Basically, the model inadvertently ingested a highly correlated proxy attribute for race. It was essentially learning from data it absolutely shouldn't have. And the result? It silently executed systemic, discriminatory loan rejections at machine speed. And it did this for 6 straight months.
The fallout was absolutely terminal. Regulators eventually stepped in and levied a staggering $24 million direct civil fine against the firm. And that was for gross violations of Equal Credit Opportunity Acts.
But honestly, the fine wasn't even the worst part. 62%. That number right there represents the catastrophic collapse in their top-line transaction revenues right after regulators issued a cease and desist directive and just immediately froze their lending gates. Private capital got spooked and pulled $4.5 billion in funding within just 30 days. Vanity metrics literally destroyed the company.
Now let's contrast that disaster with a European insurance conglomerate's transformation. They were suffering from massive bureaucratic gridlock. I mean, it was taking them 110 days just to launch models. But by completely re-engineering their framework and deploying automated code testing gates directly inside their Git environments, their average model time to market dropped to an incredible 8 days. And they did that with a 0% high-severity residual risk leakage rate. Their GVI peaked at an elite 0.92, which ended up saving them over 84 million euros annually. Talk about a game changer.
Let's look at one more triumph here. Apex Global Bank launched a generative AI customer service network called ApexBot LLM, and they utilized a rigorous telemetry-driven scorecard. At month 4, their real-time input filtering nodes suddenly caught a cluster of 18 malicious, indirect prompt injection attempts. But their automated guardrails caught the deviations in just 14 milliseconds, immediately routing that traffic to safe fallbacks. By having hard telemetry in place, they successfully defended over $16.2 million in risk-adjusted bank capital.
So the crucial point is really seeing what a level 4 managed, telemetry-driven scorecard looks like in reality. Look at this. You aren't measuring seminar attendance anymore. You are measuring a 100% data lineage completeness ratio, a rolling hallucination index of 0.008, a governance velocity index of 0.91, and a net value defended metric of over $16 million. This kind of dashboard provides an executive committee with absolute empirical proof of both performance and regulatory compliance.
Which brings us to the ultimate provocative question that you really need to ask of your own organization today. Are your AI safety controls a bureaucratic roadblock, or are they a high-speed strategic accelerator? Because at the end of the day, you simply cannot govern what you cannot measure. Now, if you're feeling inspired to audit your own metrics and transform your enterprise's AI infrastructure, definitely check out Chapter 24 and the rest of the massive 500-chapter AI Governance and Responsible AI training course. It provides all the deep technical dives and templates you're going to need. Thanks so much for learning with me today on this explainer, and I will catch you in the next one.
Welcome to the Explainer. Today, we're strapping in for the ultimate operational stress test. We're actually pulling a scenario straight out of Chapter 25 of the AI Governance and Responsible AI 500-chapter extended training course. If you're familiar with that enterprise-grade material, you know we're in for a wild ride. We're going to walk through a live, multi-million-dollar runtime disaster. This right here, this is where theoretical governance collides with a brutal code-red reality. Okay, let's dive into this. $120,000. That is the staggering amount of cash bleeding from our corporate treasury every single minute as we speak. I mean, this isn't some end-of-year projection. This is active liquidity just draining from the balance sheet at literal machine speed.
So, to understand how we got here, let's set the scene for this flight simulator scenario. It's Monday morning, 8:30 a.m. at Durga Analytics Global. You've just sat down with your coffee, and suddenly your centralized console is absolutely lighting up with high-severity red alerts. A Tier 1 machine learning underwriting asset, let's call it LendMax V5, has gone completely rogue. The cognitive load of a real crisis has officially hit the fan. Now, you can forget about that serene illusion of studying static compliance diagrams at a quiet desk. Actually, scratch that, those are completely useless right now. We are firmly in the Durga Analytics cyber cockpit. We're navigating an active system collapse under extreme regulatory and balance sheet pressure, and trust me, textbook definitions are not going to save us here. The infrastructure is being torn down simultaneously by 3 distinct vectors. First up, Vector A, data toxicity from silent upstream changes. Then there's Vector B, the human blind spot. Turns out our own teams pushed unauthorized shadow builds. And finally, Vector C, the Treasury cash exfiltration pipeline, which is actively burning our capital. We need to isolate the trigger, fast. So what actually pulled the pin on this grenade? Well, the core technical trigger here is concept drift. Over the weekend, an external credit vendor silently changed their database schema formats. Yeah,
They updated their system without an API version notification tag. That single move poisoned LenMax v5's neural layers with entirely unexpected data structures. And the statistical fallout is just brutal. This data toxicity caused the model's Population Stability Index, or PSI, to skyrocket from a perfectly healthy 0.04 to an abysmal 0.38. The algorithm essentially entered a recursive bias trap. It started misinterpreting normal transaction records as high-risk defaults and automatically slashed approved credit limits for female applicants by a shocking 80%. You might be wondering, why on earth was it allowed to fail so spectacularly? It all comes down to an egregious human blind spot. In a classic case of chasing an aggressive velocity metric, the developers bypassed the central safety checks entirely. They literally forced an unsigned, untested code container live on the European production grid without a certified data card, all just to hit a sprint deadline. We're talking about a catastrophic level 1 process maturity failure. Let's translate that engineering failure into CFO math, shall we? Because this malfunctioning algorithm was operating without active limit guards, it is erroneously allocated $14.5 million in uncollateralized retail credit in just 72 hours. That is pure, unadulterated, compounding financial damage. And this brilliantly illustrates how we transition from panic to structural control. Enter the 4-phase tactical mitigation playbook. We have to execute these operational engineering actions sequentially, flawlessly, and at machine speed if we want to contain the collapse. Here is our ticking clock. At T plus 15 minutes, we execute surgical portfolio isolation. At T plus 45, it's forensic data triage. At T plus 90, we transition to boardroom value transmutation, basically defending our actions to the CFO. And finally, at T plus 120 minutes, we mount our regulatory defense. Let's get phase 1 going. All right. Here we have the actual hard-coded infrastructural kill switch in action. This Python script is evaluating live telemetry bounds, like that PSI score and the bias ratios we talked about. Because the thresholds were breached, it automatically issues a routing veto at the API entry layer, isolating the rogue container in a matter of milliseconds. Boom. Phase 1 is complete. Because we built a smart routing system instead of relying on some blunt power plug shutdown, live user traffic is instantly diverted to safe, rule-based credit templates. The core business operations just keep on processing without a single millisecond of downstream gridlock. The bleeding has officially stopped. Now we move to phase 2, forensic triage. Look, we don't rely on frantic Slack messages or verbal assurances from panicked developers here. A true governance architect pulls raw telemetry directly from the code tree. A terminal command line trace exposes the exact upstream schema modification, proving the structural process breach and pinpointing those missing data cards. With the forensics clearly in hand, we execute the root cause remediation. We build an automated data ingestion schema, contract gate. This Python layer sits right behind the intake worker, inspecting upstream packets and programmatically dropping any corrupt incoming data before it can ever infect our neural networks again. Problem solved at the source. Okay, the technical bleeding is stopped, but it's 10:30 a.m., and the true war is just beginning. The New York State Department of Financial Services and the European Data Protection Board have just walked into your executive boardroom. They want answers, and honestly, they have the authority to tear the company apart. The regulators aren't messing around. They're threatening to levy an immediate 7% global annual turnover fine for algorithmic discrimination and operating rogue shadow software. For a firm managing $120 billion, the stakes literally could not be higher. Your CEO looks directly at you to defend the enterprise.
So you step up and present the phase 3 and 4 metric-driven boardroom defense. You bypass all that abstract legal positioning and map every single technical mitigation action, like those automated schema gates and demographic parity scripts, straight to strategic C-suite protection. You're completely dismantling their claims of negligence with cold, hard operational data. And then you hit them with the loaded corporate finance parameters. You lay out the value defended metric. You prove empirically that your automated governance systems isolated the threat within 15 minutes, actively protecting over $17 million in daily risk-adjusted capital. Checkmate. So, the crucial point is this: absolute non-repudiation. By providing an unalterable, cryptographically signed, technical audit trail, you win unconditional clearance from the regulators to lift the infrastructure shutdown and safely return those compliant systems to live operation. You survived the 4-hour simulation. You proved that vanity metrics collapse under pressure. But as we wrap up this explainer on Durga Analytics' powerful enterprise framework from Chapter 25, I want you to look at your own organization right now and ask yourself, when the system inevitably fails at machine speed, is your AI governance just a verbal promise on a textbook diagram, or is it a hard-coded kill switch?